Alright guys, give me a second here. I'm trying to get something working over on the YouTube side of things. Give people a couple minutes to pop in here. Okay. All right, good. So what are we working on today? So we already did the recording, so we got the recording stuff done. Let me go pull up my, see if I can check one last little thing over here on the, checking one more thing. Hold on a second here, guys. Want to see if I can see the connection on this. Okay, yeah, I see it. Okay, good, good, good. All right, so I'm gonna pop myself up here. You guys should see me. All right, good. So we did our recording earlier. You know, we run this professional Linux users group, and this is a place where we hang out, we talk shop about all kinds of stuff. We're up to almost 3,000 engineers, and the goal of it is to get you guys into doing this stuff professionally, right? Taking you out of just being somebody hanging out and, you know, maybe you're playing around in the space, but you want to get better at it. So what I'm doing now, I'm already done with all the work for this week, right? We did all the stuff. If you guys have questions about the course or you want to know about that, we can talk about that. But I thought I'd show you, this is a talk I did back in August. We're up in October now. And this is a talk that I gave about engineering. So typically people start, if we talk about how people start in their career, they start over here on operations work. They do a lot of stuff over here on the left. And then, you know, there's problems and things happen and they try to optimize the system. And then over time, they come over here and they start doing more systems engineering work. But as engineers, you have to understand engines, how things cycle through a set of processes. So, you know, I've given this talk a few times. I think I've even recorded it. But I thought I'd pop it up and we just sit around and talk about like what engineering is and the generics of it. But then if people want to dig down into any of the specifics, we can do that for sure. So we'll kind of do that. I'll give people a couple more minutes to kind of pop on and then we'll go. I won't probably do, yeah, this isn't going to be us being super serious. But if anybody's got any questions about anything, we can talk about them. I could pull up, you know what? Just for fun, we'll pull up some Brotato too, just in case we need to do a little Brotato in today. Because again, it doesn't have to be super serious. We're done with all the work for the week, right? We've done all the work stuff that we need. So I'll put some Brotato up in the background just in case we need to play some video games while we're hanging out here. But maybe we'll do that as we kind of go, and I'll give you guys some time to hang out there and do whatever. But the question here is why engineering? And when I gave this talk, I kicked off the start of a weekend that we had. Some of you guys were around for it in the Professional Linux Users Group. That was our 5 years on Discord and our 10 years running the group. And the goal of it was to just get people thinking about, you know, using Linux and systems engineering. And I had a bunch of people come in and do talks with us. And a bunch of those talks did get recorded and are up on YouTube. So if you guys need that, I don't have like a playlist for them, but they're on our YouTube. X Shanyam, how's it going? So let's talk about why engineering. Here's a little bit about me. I'm a guy that does engineering for fun and profit, right? I obviously do it professionally as a systems engineer and high performance compute guy. And I also teach it. I've been teaching engineering for 16 years at the college level. I've worked on hundreds of thousands of systems, and I've built them up and I've automated them and I've designed the build process for them. And I've done that all over the industry. A lot of it for defense contractors and federal government, the U.S. federal government. I've worked in building and engineering roles, and I've been in passive and active security roles, depending on where I've landed. I've been a trainer. I've trained engineers and that kind of stuff. I've taught as a college professor over 5,000 engineers now. So people, well, engineers and people that wanted to be engineers, right? I've sat in over 350 technical interviews as the interviewer, so I show you guys some of that stuff, and we've talked about that. I run Prolog. At the time, it was 2,300 members. We're almost at 3,000 members now, so I'm going to have to update this slide. And then I have a book. The book's not required for any of this stuff, but I like to let you guys know it's there in case any of you guys want to get it. It's over on Lean Pub or whatever, right? That's a little about me. And then I say, why do we do engineering? So the whole point of this discussion, the whole point of what I'm showing you and talking about is why engineering. That's the overarching thread. So, and the reason we are engineers, or why engineering, is because science explains the way the world works, right? We make an observation, we ask a question about it. From that question, we form a hypothesis of how we think things are going to work. Then we make a prediction about that. We test the prediction, and then we keep iterating and spinning to find more questions. This, by the way, this is how research works at the doctorate level. You know, people have done all this work, and there's all these articles out there. But as you start to do literature reviews, you start to find gaps, and people point out other places that research could go from the things that they've done. And now you have more and more. You kind of like, it's almost like you're laying bricks as you go. You know, you're like that Roman army building all roads back to Rome, and you're like laying bricks as you go. Or if you ever saw people build like the rail lines, they would build the lines as they went, and there was nothing there until they, you know, laid everything out and put the rails down. It's the same kind of idea here with science. Science does these things, but engineering applies that to the real world and makes repeatable practice out of it. So everything with engineering is actually scientific method applied to real life, right? So that's a thing to understand. If you don't understand the scientific process, or you've never been taught it, here you go. Make an observation, ask a question, form a hypothesis, make a prediction from that, test it. You either are or aren't right, you throw away all the bad ones, and then you just keep going. And you might say, some people are better than others. Yeah, well, you don't know how good you are until you start doing it, and so you start trying it, right? And you might say, well, Scott, so you just start trying to stand up, like, you know, you stand up this mouse you have over here, and then you got your phone and you stand up. No, we build on what other people have done, obviously, right? We start with a working thing and we go from there. But engineering is this idea that we can apply these things. All right. So anyways, why engineering? Well, because it's not being a doctor. I love that one. It's not being a lawyer, right? These are these other things that are smart and good technical things to do, but like, I don't want to look at that, and I don't want to read all that, so I don't want to be a doctor or a lawyer, so I'll go be an engineer, right? All right, so anyways, why engineering? Again, businesses run on repeatable, accurate processes. That's true. Businesses that can cycle through and do things quickly get what's called a competitive advantage over other businesses. And computers will sometimes help them do that, especially computers that are stable, accurate in their timing, and accurate in their availability of things and all that kind of stuff. And Edwards Deming said, if you can't describe everything you do as a process, you don't know what you're doing. So we end up between those chair, read all day, and surge the configs. Lesser I'm not sure exactly. So we end up between those chairs, read all day, and surge the config. Yeah, I don't know exactly. We're somewhere between those things. Sure, yeah. As an engineer, by the way, as an engineer, you never know where you're going to land. You're going to be doing something engineering, but who knows where. Doomhelm Admiral, that's something I've been telling people for a long time. Yeah, Deming he rebuilt World War II after Japan. He is part of the reason Japan is the powerhouse it is because of what Edwards Deming wrote. He did a little bit with total quality management, but he was real big in Six Sigma in the development. But yeah, he had his 13 points. But one of my favorite things that has stuck with me the most about what he said is, if you can't describe everything you do as a process, you don't know what you're doing. And it's true. There's another way that people say it in like operators, for like guys that are out doing what we call operators, are the guys who go operate in war zones and stuff, and it's this idea that if you can't do it slow, you can't do it fast. There's an old saying like that. If you can't do it slow, you can't do it fast. And that's true. It is true. But if I'm just like, well, to get this bottle open, I kind of hold it like this in my hands, and then after a while I kind of and then I can just drink the water. And you're like, mother effer, you held it with one hand and you turned the screwed lid off the other hand, and then you poured it into your mouth. And I'm like, well, yeah, that's what I did. That's what I meant. But you're like, but you sounded like an idiot when you were trying to describe it a second ago. And I'm like, so you have to, as an engineer, as engineers, we understand the way that things cycle, the way that processes occur. And Edwards Deming was a good example of that. And his studying him is a good way to understand like improvement processing. And then we have ways that we do that. And I've told you guys about that. Like down in our Discord, there's the Six Sigma and Lean Six Sigma free tests that you can go take. You can go take those tests for free. Saber, if you do Discord, you can see this stuff. I don't have a socials because I don't really do too much social stuff. But we do have a YouTube one as well, a YouTube channel. But if it can be measured, it can be improved. That was Peter Drucker. He was a big part of American industry. So Deming was a big part of Japanese industry, which they're still a powerhouse. And Drucker was a big part of American business ownership. And I want to say it was like 70s and 80s. He was a little before my time, but I've read about him quite a bit. Peter Drucker and Edwards Deming, right? So those guys are guys to go read about and understand. Especially, you'll read and work with them a lot in your master's type programs if you ever do that at the college level. You know, your start of your graduate work and that kind of stuff. So then I say, why engineering, right? Because with engineering, we build engines or systems that cycle. Everything we do in computer information systems, CIS type programs, is an engine that cycles. So this is just some 8-function cycle. Some of you may recognize what that is, but it is something that happens in a specific order every time. It can't happen out of order. It has to happen in order. And from this, we can understand that engines always have an input of some type, sometimes multiple inputs, and then they process things, and then they have an output. And if processes use up the inputs, that's fuel. Typically, we call that like fuel. Like if you're adding fuel to an engine and it's using it and then making a waste, the waste is typically an exhaust, right, of some type. If something is processed but it's not used up, it's known as a catalyst, meaning it sits there and it causes a change but it doesn't itself get used up. That's a catalyst. And there's a bunch of these if you talk about, you know, chemicals and physical engineering and all these other types of engineering. But at the end of the day, as engineers, we build things that cycle. You guys, if you know what this is, you can say it, but I don't, you know, this is something I learned in the infantry many years ago, right? But it's something that always goes. Feeding, chambering, locking, firing, unlocking, extracting, ejecting, cocking. Those 8 things always happen in order, and then they restart the cycle, right? So why engineering? Well, because we can model systems to teach and understand. So if I wanted to teach you guys about this thing in my hand that's doing these 8 things, and I'm just sitting there going, well, you know, you do this, and then you do this, and then you do that, and then you're done. You guys would all be like, this guy's a fucking idiot. This guy doesn't know what he's talking about, and I don't. But if I say instead, I can feed, and then the device loads whatever is in the magazine that we put into it, and that feeds, and then it slides up into the chamber, and then there is a cam pin that causes the in this case the bolt face to turn, right? Because there's a cam pin that causes it to turn out of its bolt carrier group, and then that chambering and locking happens so that a firing can occur where compression allows some projectile to go down a barrel of some type, right? And then as the gas pushes the bolt carrier group back, it causes the cam pin to turn and unlock the bolt face out of the chamber, and then it starts the process of unlocking, extracting, ejecting, cock. And I can talk through all of those things. Then we could start to talk about teaching people it. I can say, well, okay, feeding takes about 0.3 seconds. Feeding an object of exactly 5.56 millimeters, because that's what type of object we're talking about. Feeding can only occur in the first step of the cycle. It cannot happen anywhere else, right? And you start to learn about this, and you go, okay, I understand feeding. Now, well, what's that chambering? Okay, well, it's sliding forward, and then it's starting to push the object that's being fed into the... And I'm starting to understand how this thing is cycling through, because then if something ever breaks, I can very quickly understand where it breaks. Well, we're going to get to that here in a second. But again, with engineering, if we model systems, we can outline and then teach them. So when you hear about like the OSI model and you're like, oh man, why do these guys have this 7-layer model for how they teach networking? Well, because it's very easy to break down the pieces and then to teach with that, right? And I always talk about the OSI model as, because that's how I've been teaching people forever. So why engineering again? Because we can record output for variability. So again, you've got this input process output of your system, and you've got your fuels and your catalysts and your exhausts, right? All these things that are happening in any type of cycled engine. But right here, we can report output for variability. So consider this example of that 8-function cycle again. And right here, when this firing occurs, something is ejected from the, different than this type of ejecting, something is expended out of the device, right? And sometimes there's variability there. Sometimes it's 2,300 feet per second. Sometimes it's 2,303 feet per second. And then you find after, 4,000 tests, at test 4,000, you get 2,295. And now we can start to build variability charts and histograms and all these other things that we can use to record. Well, what about the input causes this output to be different? There's all kinds of things. There's the grain of the device that's being released. There's the amount of charge that's in this device. There's all kinds of things that can affect this, but I can start to now test for variability. So actually that's this next part. So we record first, and then we start to model the variability. And what we do for modeling, this is a histogram right here. A histogram is a look at the containers that contain all the blocks of output. So in this case, let's say, and actually this is a pretty good example here. Let's say that 2,300, as we go through 4,000 test cases, we get 2,300 as our mean. 2,300 is our mean. And it happens to be right here in the middle of this. And then we have, these are typically reported as standard deviations from the mean. But let's say within those standard deviations, we find that we go to about 5 feet per second less, so 2,295, all the way up to 2,303 or even 2,305 above. So the mean right here is 2,300 at this point. And then we would have all of the instances to the left and the right of that. This is actually not a histogram. This is a distribution chart, and it's a normal distribution chart. There's other types. There's bimodal and what's the other one, like poison. It's PIOSON. It's like whatever, however you say that. It's different types of distribution charts that we have, right? But the point is, this is a normal distribution, so I would expect 66% of everything that happens to fall within one standard deviation, and then I think it's like 87 or something to fall within the 2 standard deviations, and then within 3 standard deviations, I would expect like 99.7% of all occurrences to happen in here. You may have some real low outliers, like a not quite a squib round, that's a 0, but you have something that is only like, let's say 1,100, and it's so far out and it's so rare that it still gets a data point. But when we actually do our analysis of things and do our linear regressions, we tend to throw out some of the lowest and top percentile of things because they affect the overall mean too much, right? But my point in saying all that is why engineering, again, is we can model variability and improve by tracking things. So again, you can track things, but then you can track things and start to improve. We've got an upper control limit and a lower control limit of maybe what we load into this thing. And then that's going to control typically an upper and a lower control limit of like the speed of the output of this thing that's coming out, right? Of, again, whatever this thing is that we're looking at as an engineer. So again, why engineering? Because we can model variability and improve a system, right? Some cycle of things, right? Then we come down here, and why engineering? Well, because we can log and checkpoint things. So as this system is going through, maybe as some, thing is cycling through whatever it does, it's sending out outputs. Like maybe when it chambers, it gives us a timestamp, and in that log, it says chambering complete. And then it comes down here, and maybe when it cocks and gets ready to go through the whole cycle again, because cocking is the last thing before it feeds through the whole cycle again. And then here it says cycle complete. And these logging, when we start to log things out, we can checkpoint, okay, we got to here, we got to here. Well, what can we do with that? What does that help us to improve? Well, we can now troubleshoot. If I am running this thing, and I'm running through these 8 functions of whatever this thing is, and I get to here and I get a timestamp, and then I never get to here. I never get this timestamp. Well, then something broke in here. And some of you are going to very astutely say, looking at that, well, fucking where did it break? There's like five steps there that it can break. And I say, you're right. You're 100% right. Something broke in there. Where? So now you start to talk about granularity. So now we think about granularity. Well, this isn't a very good granularity of logging. We should log at every step. Well, what does it cost to log? Does it cost some energy? Does it cost just the system reporting something out? Well, what if when we fire, since we're already gathering that into our other data, maybe we put a timestamp there that firing is complete, and now if something breaks down here, I don't have to think about if locking or firing broke. Go to here. Let me show you this. Let me do a systems level thing like this. We do this a lot, but let me ping let me ping Rocky 18 real quick. All right, we pinged Rocky, and then let's ping www.google.com. All right, we got that. All right, good. So hold on real quick. I want to troubleshoot Rocky 18 real quick, and I just pinged it. Do I need to get up and go to my rack back here and check to make sure Rocky 18 is on? Do I need to check if that server that responded to me over ICMP is on? Do I need to go to that server via like the console now, right? And I'm on Rocky 18 and I see that he's up. Okay, do I need to check if his network cable is plugged in? Like if he was a virtual machine, do I have to, if ETH tool, ETH 0 or whatever, do I have to check that his Ethernet's up? No. He's responded all the way up to layer 3 of the OSI model. I've been able to ping him. Do I have to go to him and make sure he's got the right IP address in the network? I mean, barring other weird stuff in our network, like people just turning on systems and giving them weird IP addresses. No, I that machine worked all the way up to layer 3. I don't have to check the other layers. Well, how about this? I pinged out to Google. Well, I gave it a name, but it went and resolved to an IP address. Do I need to check this box to make sure that his DNS resolution is working? No. He just pinged out to Google, no problem. He got all the way out. All I did was give a name, and he resolved an address. So, do I have to go dig into, is DNS working? Can I dig, www.google.com? Do I have to use these tools to go find that? No, I don't have to do any of that because I got past firing here. If I don't get to cocking, it's somewhere in here that there's a break. Yeah, so you guys see this is engineering. Like we think about granularity and how we log things. But I want to ask you something. If you didn't understand this process, if I hid the process, right? I just came in here and I drew a big I took my pen and I went, okay, you don't know this anymore. You don't know what was next, right? You didn't know these 3 things because for some reason you just didn't know them. Could you tell me what happened between here and here? Could you try to figure it out? No, because you don't know the process. So that goes all the way back to this. Edwards Deming said, where is he? If you can't describe everything you do as a process, you don't know what you're doing. And you will never be able to troubleshoot properly if you don't understand the process to start. This is why engineering is so important as an engineer, to understand how these things all... anyways, it doesn't matter. All right. So then we come down here and we say, why engineering? Well, because now we can hack things. If I understand how a thing works, I can start to hack what it is. Now, it is very common for people to think that hacking has something to do with getting into systems. The term hacking has nothing to do with getting into systems. Hacking is a process of understanding a system, typically by testing inputs and output behaviors to map system function. That is what the term hacking means. Hacking has nothing to do with getting into stuff. Hacking has nothing to do with I'm in and the movie Hackers and all that kind of stuff. That is just an incorrect application of the word. Hacking has always meant hacking away at a system until you map its input functions to its output functions. Now, does hacking help you with phone phreaking and cracking into systems and system compromise and all those things? Yeah, it does, because you're using the same process of hacking against a system. But I just need to emphasize the term hacking does not mean unauthorized access. You can hack away at your own systems. You guys can go into, you guys have 100% access to my lab environment right here. I have never told you guys you couldn't do anything in there. You guys can get into the Rocky boxes. And if you hack away on those Rocky boxes to figure out what they're doing and what networks they're on, good. That's good. But there's also labs that'll show you stuff. Labs are the opposite of hacking. Labs are just walking through things or whatever. But yeah, so we can hack things. I can start to test random structured input, 1, 2, 3, and then maybe I find out that feeding smaller things in there still works, but feeding bigger things in there fails. And then maybe down in locking, I find out that first thing that I put in there errored. My second one errored over here and gave these weird error codes. These are me messing around with actual web error codes that wouldn't work in this thing. And then this last one, 3, makes it all the way to end with no error. So we can hack away at a system if we understand how to feed it things, and then we can get different things out. Have you guys ever went to like a YouTube video and seen, this is a common video, it's not very safe to do, and I'm not telling you to do this, I'm just telling you you can find YouTube videos of it. Do you guys know what a 50 BMG looks like? Hold on a second. Hold on. I've never shown this on stream before. This was a gift from a friend. This is a 50 caliber round right here. It is huge. If you look at it compared to my hand, it's also a bottle opener, right? It's been emptied. There's nothing in it. Put it right there. This is huge. It's like almost the length of my hand, right? It's really big. Did you know you could take one of these big 50 BMG rounds? I'm not telling you to do this, guys. Do not do what I'm about to tell you. And you can go put this into a 12 gauge shotgun and shoot it. You guys ever... Don't do that. But you could do that. And that is a hack that somebody figured out, that this thing will travel at least once or twice down the barrel of a shotgun until it, probably blows the chamber and hurts you pretty good. But my point is, you can hack a system by giving different input functions. There's actually one in this type of device that I'm talking about, where instead of using 5.56, you use... what's that other round that goes in there? There's a round that almost fits but doesn't, and it'll basically cause a bunch of problems for the system. This type of system that I'm actually talking about. But hacking is the process of understanding a system, typically by inputs and output behaviors. So I want you to understand that hacking is a subset of engineering. You are trying to map out what's happening. Maybe this is a closed box, what we call a black box system to you, and you're sending different inputs to it to see what happens. All right. Yeah, Monkey Man, don't do what I said with one of these things. Plus, these things are like, these used to be like $3 or $4 each. This is a bottle opener one that a friend gave me, which is funny because I don't drink, but I do like this. This thing's super heavy too. But these are now like $6 or $7 each if you're buying the actual thing. Also, it's got a primer that's already been fired. All right. So right here, now we can secure the system. We need to ask ourselves, why would I allow somebody to do this to my system that I want to keep up? And I want to make the system operational so my administrators can run it. Remember I told you guys, if you do systems administration course with me, every focus of our systems administration course is uptime. I want you guys to keep systems up, and I want you guys to worry about your key performance indicators through that whole course. But in engineering, I can secure my system by not reporting shit back to people. It should be a black box to them. And I should secure it such that people can't do this testing of random structured input. Maybe I start to time them out. Time out. Where's my little thing here? Yeah, time out. Maybe I have some kind of auth, right? You need some kind of, what do we call them? A JWT, a JSON token. Some people call that a JOT. I never knew how they got JOT out of JWT, but like a Java Web Token, right? And now, did I say Java? Yeah. What did I say earlier? It's a JSON Web Token, not a Java Web Token. JSON. And then they have this structured thing that can then allow you to give authorization and then access, right? So they authorize that somebody is who they say they are. Authenticate, and then also authorize. So it's authenticate that they are who they say they are, and then authorize them to do things in your system, right? So that's like an engineering thing. Crispy said, can I ask you a question regarding which field is a good one to get into in IT for the coming many years? Crispy, I don't think Linux systems administration is going anywhere, meaning I think that it's going to be around for a long time, and I think that you can stick with that for a long time if that's something that's interesting to you. I don't think that that's for everybody. Not everybody wants to work on Linux boxes all the time. Most of the people that I deal with do want to work on Linux all the time. They want to hang out and talk shop and just keep our servers all working and that kind of stuff. But no, I'm a big fan of Linux systems work because then you can branch off into all kinds of other things. I don't think high performance compute is going anywhere. In fact, I see more and more work in high performance compute areas. The stuff that I do now currently is bleeding back towards all this AI stuff because they're making AI workloads work on my high performance compute systems now. So I'm watching a lot of people do that. Programming, cybersecurity, data science, blockchain. For me, I think that like you're always going to need cybersecurity, but I don't think cybersecurity is entry level. Like I think people really want to just get into cybersecurity because they think, oh, I'm going to be a hacker man's. But it's like to secure a system, you have to fully understand that system. You have to understand where inputs come from and where outputs are going. And like to get into cybersecurity, I think you should know networking and systems and how the programming side. I think you need to know a lot of things to do that. So I don't advise starting out in cybersecurity, but maybe some people are doing that. Data science is fine, but you're going to find yourself pulled over towards stuff that is kind of engineering and systems work adjacent. So I guess it depends on how much you want to do that kind of stuff. Programming's fine, but just remember a lot of times when you're programming, you're sitting around and solving puzzles and looking at code until your eyes bleed. So I kind of stay out of that space, and like my scripts and things that I write are more like programming light. I don't professionally code, right? I do quite a bit of writing of code, but it's not programming. I'm not writing applications that are running for years and years and that kind of stuff, right? But I understand the basics of how those systems work, right? Because I interact with those people a lot. All right, so anyway, so why engineering? Like we can secure our systems, and then because we can secure against intrusion, right? And describe the events in a structured way. Let's say that I had some event happen. Somebody did those three things to try to get into my system. And I come down here, and this is what's called the Diamond Model of Intrusion Analysis. So if some of you guys want to go look that up, the Diamond Model of Intrusion Analysis is a way for us to describe what happened in an event. So if you guys heard a lot the last few years where like Sony got compromised or Target got compromised and lost everybody's credit card information and all this stuff, what happened was there was an adversary against a victim, and that is the socio-political axis, AXIS, right? And what happened is some adversary attacked a victim for some monetary, political gain, prestige. You know, they wanted to be the coolest techno nerd. For some reason, somebody attacked somebody, and they did it for some reason, right? And that's the adversary here. The infrastructure to the capability is called the technology axis, and this deals with the infrastructure that the infrastructure here is the defense side. What do I have to protect myself? And the capability of the intruder to try to break into that. So this is the adversary versus the victim, or the socio-political axis, and then the infrastructure versus the capability axis, right? And there is a whole bunch of stuff for you guys to go spend. Like if some of you want to go read about, you know, if you're like, I want to go spend some time in that and I want to go learn that. The Diamond Model of Intrusion is out there on the web. You can just go here and you can just say Diamond Model of Intrusion Analysis. Oh man, come on. Diamond Model of Intrusion. I don't even know what that crap is over there. And you can go find the original, And where's the original? I think it was the Threat Intelligence Lab that no, it was Active Response, maybe? I think these were the guys that originally published it. But here's the original publication of the Diamond model of intrusion analysis, approved for public release. Distribution is unlimited. So here you go, boom. That should pop up on both sides for you guys. And you can go read about how this works. And you can go read about the social political and then the model. You can go look at what their model looks like. And then different features that are added, timestamp, phase, result, direction, methodology, and resources that are used to extend the model and then cause it to be more useful. And this is a good one. If you're not familiar with how offensive security operations happen, this is a good way to start looking at how that happens. Then another one that's big is the attack.miter. I've been pulling this one up a lot recently. But the attack.miter is this framework all the way from reconnaissance over to I think it actually ends right there. Yeah, impact. So this is how attacks occur from a high level as a model. Now, things can be skipped, but this is the high level model of how attacks occur. There's the initial reconnaissance, resource development, and maybe gathering capabilities, your initial access, execution, persistence, privilege escalation, defense evasion. So how are they evading things? And look at some of these. Some of these are really, really long. And mostly I pulled this up to explain to you guys how one of the defense evasion techniques is to do indicator removal. And indicator removal makes sure that they have wiped all of your logging, right? They make sure that you have no logging on your system. Well, if you're sending logs off in real time, you at least have the last events before they deleted the logs, right? So these are the kind of things that you can kind of start to look at there. Anyways, so there's a whole bunch of those. But again, for engineering, we can describe intrusion and events in a structured way. With engineering, we can also design how incident management is going to occur. We were talking about incidents earlier today in our Linux Systems Administration course. By the way, we're in week 4 of that now. Week 4 started yesterday of our 16-week course on getting into Linux Systems Administration. That's a free course, guys. I'm never charging anything on Discord, but if you guys go to Discord, right? 1, the bot will greet you if you hang out in there. And 2, if you go to Prolog Projects, these are all the pieces of it. You can go download them. You can throw them in your sack and run away like a cartoon villain. I don't care. There's a bunch of discussion posts that you would start to work on. It looks like discussion post 1 is finally done. People stopped posting into there. But then you've got all the way up through Unit 4. People are still posting. Actually, nobody's even posted in those ones yet. So hopefully people will start posting in these ones. I did not mean to call this one. Oh, well, that's fine. I need to change the name of this. Hold on. I change the name of this thread. Oh, all right. Well, fuck it. I don't care. I'll change it later. View the thread. Change the name of the thread. Edit thread. Unit 4. Discussion. Post 2. Operations bridge, right? There we go. Escape. Better. Okay, that looks better. Anyways, the point is there's a bunch of stuff up there. Is the age of 24 too late? Well, I don't know if you can tell, but I'm older than 24. And I think that you can still get into this. I actually didn't start my engineering. I started at the age, well, so I was Army infantry from the age 18 to 22. Turned 22 in Iraq, by the way. And then I got into engineering while I was still in the Army, and I started doing that stuff. But I didn't get into doing tech work until I was 22. And then I've just been doing it for the last 21 years now. So yeah, I think you can do it. Yeah, I think you can still get into it. I think you can keep your brain sharp. You're gonna find stuff as you get old. 24 is still pretty young. As you get older, you'll start to notice things like go. Like I don't type nearly as fast as I used to. I used to have about 130 sustained words per minute, and now I'm I'm probably lucky with cleaning up my errors to hit about 70. I'm not nearly as fast as I was. I tell people I used to play like Unreal back in the day, which is one of the early Instagib shooters, and I was like a 15 to 1 KD ratio. And then I was playing Destiny in my late 30s, so a few years back. And I remember my KD was only 2 to 1, and I was like, these young kids are popping me off all the time, just murdering me. I was never as good as I got older. But anyways, the point is, you could still do this stuff. Yeah, I think you guys can learn this stuff. Yeah. So, I think you can definitely start early, and 24 is still pretty young. You're gonna have some adjustment, and you're probably gonna have to study a lot. But we have hours, maybe even in the hundreds or thousands of hours range of stuff to study down in our Discord. That's kind of directing people towards being a systems administrator, because that's what we want to do. We want to get you guys that are doing this as a hobbyist and get you doing it professionally. So, all right. So that's cool and all, but why engineering, right? This whole talk has been about why engineering. So why engineering? Well, because nobody's going to pay you to hack. I don't know if you guys know this, but like just sitting around and like hacking away at systems and doing cool stuff is cool, but it doesn't, like, nobody's going to pay you for that. What they're going to pay you for is engineering, which you can sit around all day and hack, but you got to get better at the planning, and you got to get better at the documenting part of it. So I'm going to talk about the two pieces of planning and documenting. So some of you guys who probably sit around and hack away at systems all the time, and that's valuable again, but it's not going to pay. Nobody's going to pay you for that. They want you to plan stuff out and then document it so that it can be built. By the way, we're doing a project in the Linux Systems Administration, and I mentioned it today. I said, in this project, you are kind of moving over to the engineering role side of things, and I want you guys to know that this is like the crux of it. Everybody wants to just sit around and hack shit, but nobody's going to pay you to do that if you're not planning what needs to be done and also documenting it when it's done. So, all right, we'll do that next, but because I've talked for 42 minutes, I'm going to play a video game for a minute. I got my little Brotato up. We're just messing around today. So if you guys want to... And by the way, you guys can ask me questions about anything we've done so far. I'm going to play the Techno Mage because I'm not very good at this guy, and I'm trying to take him to a very high level. So if any of you guys got questions about the systems engineering stuff, let me know. I've also purposely left the closed captioning going so you guys can see that. I'm surprised nobody's asked me. I think somebody asked me yesterday how I do the closed captioning. It's PowerPoint, in case you guys are wondering. PowerPoint will do all of that stuff for you. Multi-arm guy with 6 is actually fun, sure. We're going to take that, and we'll hold on for that, and we'll get more icicles. All right, so this guy is a Techno Mage, the character that I'm playing right now. He gets, the more elemental damage he has, the faster his structures are. The more structures he has, the more it feeds back into elemental damage. So you really want to take this guy and get as many structures as you can as you go, and also get really high elemental damage. So he's actually probably my favorite character to play right now, because there's a lot of fun aspects to Brotato, but for me, getting a build that's going to go really, really far in the end game is my main fun. So I've been trying to get this guy. I've gotten this guy a few times up past level 20, and that's the end of the game is level 20, or wave 20 as they call it. But what I want to do is I want to get the game. I want to go like all the way up as far as I can go. Crispy said, "Do I have a roadmap for like getting into systems engineering?" Yeah, right here. I'll show you a start. You come to our Discord if you're in our Discord, and you go beginner start here. And we have like the basics of Linux. This is probably, I don't know, 10 hours or so of Linux. There's a bunch of free certs if you just need to start buffing up your resume. The Six Sigma and Lean Six Sigma stuff, excuse me, they tie back directly to that Edwards Deming guy that I was talking about. There's also API stuff, which is important to understand because you're always going to be interacting with an API if you're dealing with the cloud or any of these DevOps concepts. Chaos engineering is directly related to your site reliability engineering stuff. IPv6 is kind of the future of networking. And these are all free certs right here. Nothing here costs you anything to study or to go actually get. But now, so what does it cost you actually? It costs you time. Can't go out partying on Friday night. You got to sit and study. You have to, you know, this is what it is. Some of you guys can go, well, you were here Friday night. Yeah, I was messing around on the system. But yeah, so that would be my roadmap. And then we've got our Linux Systems Administration course, like if you just are trying to get into the field somewhere to move over later, this is it. Exunium, how much time commitment are those? If that can be mentioned in a bracket next to it. Yeah, I mean, I can't tell you what everybody else studies. Like I tend to absorb stuff quickly, but I'm also in the field for 20 years, so I couldn't tell you what somebody else might take on these. I really couldn't. Also, I did this all through college, so for me, this is just reading it a little bit. I mean, I've given my estimates before. Yeah. I mean, 20 plus hours for most of them, probably for the average person, 20 plus hours. So, like, if you were not working, that would be easy to do. If you were working, that would be probably, 4 to maybe 8 hours a week that you could give to it. So you could do each of these in under a month, I would guess, if you were pretty committed. That's what I would think. At least my initial thoughts on it. Let's keep that for later. Yeah. But I think the main thing is you just have to start getting into it. You have to find other... Do you guys want me to do my other talk? I got a talk on that, which is excelling in the engineering field after college. I will give that talk if you guys want. Let me finish up this engineering one, and I'll jump over to that if you guys want. If that's an acceptable thing. Yeah, you gotta take notes. Notes are a big part of it. I've talked extensively about note taking the last few weeks, so I think notes are very important. We'll take elemental, take attack speed, get another one of those, and we'll save some food, and we'll get more elemental. So Crispy, this is what I would advise, right? And this is just me as an aside. I would get a app like Notepad++. That's free. Logsec is free. Notepad, if you have Windows, is free. Right, here's my little ticker. That's what's doing the ticker at the bottom of the screen. Zotero is free. Zotero is more for like your research notes, so maybe not that. But all of these note programs, Obsidian is one that everybody's always talking about. But if I was listening to a streamer and I didn't know any of this stuff, this is what I would do. I would be like, what the hell was he talking about with DevOps? And what is a SRE, right? And I don't know what a DevOps or an SRE is, so I'm going to go read that later. But he's already moved on to other stuff, so we're going to keep going. And then, like, in our Linux Systems Administration course, I'm always telling you guys, have your notes open so that when we get to... that's my doctorate stuff. Hold on. That's stuff that's not for you guys. Let's go to... where's my Word? Here's Word. Just open up a generic Word doc real quick. Hold on. And we'll open up... where's our worksheet? This was our worksheet for this week, right? This is our Prolog worksheet for this week. And I'm saying fill it out, do your discussion questions in there, and then here's a bunch of definitions. So if you're having a hard time keeping up, here's some definitions that you can just go fill out. And then come down here and like links and terms and notes. So as we're doing our classes and as we're doing this, people are posting links and expressing terms and talking about tools that they use. There you go. Exunium, please do more about making and maintain home lab. So the reason I don't do that, Exunium, is a lot of stuff that you see in my home lab, I do not do best practice stuff in my home lab. I just mess around in my home lab often. So like a lot of times you see in my home lab is not good professional work, and I would not advise doing that stuff that I... Like, it would be like me telling you, do this, but don't do it like me because I'm doing it like crap because I'm lazy at home. And in my professional life, I have way more discipline than I do in my home stuff because I'm much more lazy about my home stuff. All right, we gotta leave these guys all back over here so my turrets can shoot at them too. Well, for the most part, but all right. But you got to keep killing these guys because you got to collect all the loot. Oh, I'm not gonna get that tree. Oh well. This guy doesn't care about range damage. He only cares about elemental damage. Oops. So there we go. More icicles. We do want a piggy bank. Piggy banks are huge. And we want more of these because these count as a structure. So I'll get more structure points for them. And then there we go. Windows or Linux? I would focus on Linux if I were you. I mean, if you want to be a Linux engineer, I'd focus on Linux. You could do Windows, I guess. Right? I don't know. I don't know where that question's coming from, but I would definitely tell you if you want to be a Linux engineer, work on Linux. So. All right. Hold on a second here, guys. By the way, I didn't hear anybody say they wanted me to do Linux systems administration, so I guess I'm not going to do that. We'll just get back to this other talk here in a minute. And that's what we'll do. Oh, also I want that because it doesn't matter that much. Let's finish this talk up real quick. All right, so why engineering? Because no one's going to pay us to hack. That's a simple fact. So you got to plan and you got to document around your hacking. The process of hacking is just failing fast. That's what it is. It's sending inputs, getting outputs to a system, whether it's at a command line or whatever. But let's talk about the planning and the documenting part of it. So how do we apply planning to the front of our, I love this. How do we apply planning to the front of our engineering? And the idea is we model the high-level steps of a new thing that we're creating or deploying. We saw earlier as we were walking through this, there were 8 functions of a thing, right? There were 8 functions of a thing. They were always cycling through. It was a cyclic operation of an engine, and outlining is critical. You got to figure out how to outline things. You have to understand what you want to make something look like. Like if you're building a brand new operating system from scratch, but it looks like other operating systems, you probably need to get better at, you need to understand how operating systems work. But if instead you're just building a server and you're using an operating system of some archetype, like Red Hat or Windows or whatever you want, I'd stick on the Linux side of things. But if you're going to use an archetype of that and apply it to a server, you may have other examples of how you do that. So what's the process to build a server, right? If you think about it for a second, maybe you've never built a server, but I need an ISO of the software of the operating system that I want to apply. Okay, so I got the ISO over here, good. I need to connect to the server in some way. Maybe I got to go physically go over to it back there, and I got to burn that ISO onto one of these, right? I got to get a little USB. But maybe over the network nowadays, in most modern times, I don't ever even know where my data center is. So I just take my data center, right? Or it's my data center. If I take my ISO and I have it on my local machine here, and then I connect to like an iDRAC or some type of connection into a system where then I can load the ISO remotely into the system, and then I can boot and install a machine the first time. Yeah, I wouldn't install a floppy. All right. So then once we get that to boot the first time, maybe from there we load some software like Werewolf on it, and then we start to host our ISO locally on a container. And then as other nodes come up in the cluster, they start to check in, and as they check in, they get told who they are, and they start to boot from the Werewolf process. Or insert Werewolf. Instead of Werewolf, it could be XCAT. It could be, these are all high-performance compute ones. It could be Werewolf. It could be XCAT. It could be any Pixie boot system. It could be Satellite. Satellite can do it. And that's Pixie is just PXE. And then it's IPXE. Those are the things. Heard that there are systems that still use floppy drives to read in keys from. Possibly, I guess. I mean, I guess. I would. That would be fun to watch, but I haven't seen that in my career. That's funny. You need to be able to estimate your time per task. This is critical. SWAG, scientific wild ass guess with your previous knowledge. So you've built servers before, and you know now that if I'm going to have to introduce a new operating system type into this environment, it's probably going to do all those things I mentioned earlier, and then I've got to harden it. And to harden it, I've got to use either the CIS benchmarks or the STIG score from the government. U.S. government provides both of those. And now I have to, it's going to take me 20 hours to take this new version and get it ready for whatever I'm doing. Crispy said, which path would I take with the knowledge I have to secure a good career if I had to start fresh in 2024? If it were me, I would start with. It's hard because I've been doing this so long, but let's say that I would start. For me, I started my career with a cert. I started with a CCNA. That's where I started. I thought I wanted to be a network engineer, and then I realized I didn't love networking. Right? I don't really love working in general, but I didn't love network engineering. I much more loved systems engineering. But I would probably start out learning Linux, and the Linux I would focus on is professional Linux that people are using. So how would I learn that? I would go probably get into either like a Red Hat or like a SUSE Linux group, and I would start to learn those things. Our group is very vanilla in that we don't care what type of Linux you use. We just care that you're using a professional Linux, or you should focus on a professional Linux. Like we sit around and talk in the chat about different things. There's one that's very popular right now. Like everybody's talking about NixOS, right? NixOS, and it's like that's cool. That's a real operating system, and it's pretty cool that it's very, very, very locked down and immutable. You can't change the OS as you deploy it, and that's great. That has a pretty cool application for like deploying things and making sure that everything's fine through like a CI/CD pipeline. But I would Crispy, I mean, yeah, I would look if, yeah, sure, start there. Yeah, I'm starting to think your questions aren't very genuine. So let's just say that's the last one of those. All right, being realistic with timing. You shouldn't give like 40 hours when you think it's going to take 20 hours just so that you think that you're going to look like a hero. You should be as precise as you can, because then that's going to kind of build down into all your tasks later, right? So don't just be like, hey, it'll take me 80 hours and then it only takes you 20 hours and you look like a hero. That's bad engineering. And that kind of stuff may bite you later in your career because people are like, he does good work, but he does it slow, right? But then predicting possible issues that can come up, we've got ways to do that. The failure modes and effects analysis, that's a thing that I've shown you guys how to do in other talks, where we do failure modes and effects analysis. Is this idea that we can predict possible issues before they even come up. But this is based on previous knowledge and like understanding of systems and that kind of stuff, right? And then what do? We build a minimum viable product. We get something working. I only got to get it to work once and prove that it works. We can also do what's called a proof of concept. And once we have that, the project checks all the boxes that we need, which is fit for use and not fit for warranty. Fit for warranty means it's going to do what it needs to in production environments. Fit for use is not fit for warranty. Like I put 4 wheels on the side of it and I can push it down my sidewalk, but I shouldn't take that thing and go push it down a mountain. That'll get somebody killed, right? It's the idea that fit for use is just checking boxes or functional capabilities, not being fit for warranty is that. Mr. Poolshaw, I'm not besmirching his name. I'm just saying that was fun for the show, but it was not good engineering. He even says one time, he's like, I just doubled whatever I thought it took, and then it gave me this other stuff. You know, give me whatever. So it's not great. All right, so why engineering? And then we have note taking. So the notes at the end, right? Documentation at the end is very critical for an engineer. I think you should take notes as you go. Screen and Tmux can log in real time. You should pull commands that are relevant out of your system. Notepad++, OneNote, Obsidian. People love Obsidian, all that kind of stuff. Clean up and prepare your initial documentation. So do a first pass of your documentation. Learn how to do Markdown or other documentation standard as appropriate. Everybody loves Markdown. There's also a standard. I think MediaWiki is another form of Markdown. I learned MediaWiki a long time ago, and I've used their standard for a long time, and it worked fine. Run redline operations over your documentation, meaning give people time to practice and work over your stuff, and kind of go from there. All right, anyways. And then produce and operational activities for your documentation. So this is actually one that I do often, and you'll learn your systems better as you train others on your systems. You can't assume that they have any knowledge of the system. You have to just even with root level operators, you just have to assume this is brand new for them, and you just have to give it to them like that. Absolute pathing helps keep operations in correct directories or operators, but absolute pathing gets really long sometimes. So sometimes we do stuff relevant, relative pathing as opposed to absolute pathing. All right. So anyways, so the conclusion to why engineering, if any of you were around for this, why engineering? Because engineering's worth good money. Businesses need their processes to run, and we know how to do it. So engineering is worth a lot for you guys to go figure out how this stuff works. So where do you go from here to focus on being a better engineer? You go and you find a group of other people that are doing engineering or talking about engineering. I'm constantly telling you guys that you got to read. You got to read a lot. You got to be involved with systems administration already, typically, or you've got to build projects that would convince somebody that you can do systems administration, right? That's one of the things that we're doing right now in the group is getting people systems administration skills and practice so that they can kind of move on from there, right? All right, so that's that part of the talk or whatever, right? Did I pull that other talk up? Hold on. Nope, didn't pull the other talk up. Give me a second here. I'll pull this over here to the side. All right. It's always got to get weird. I'll do this other. This is a talk that I did a while back. Again, most of you guys know. I don't care if you know who I am. Excelling in the engineering field after college. This was for my college students originally, but also it can be for anyone. So let's say you're not going to college or you're all done with college. Let's talk about what you should be doing to get yourself into the field, because the general consensus is people want to know how to get into this field and how to get into this kind of stuff. So let's go look at what we need to do. So here's a random quote to get you interested. Like, education is not about just filling up, pouring this into a bucket and then now you have it forever. It's more of like lighting a fire, and you have to keep that fire stoked up. I don't know if any of you guys have ever been out camping, but if you have a fire, that fire burns down because it burns all its fuel. And if you don't push more fuel into it and keep that fire stoked up, that fire is eventually going to go out. And that's kind of how IT is. If you're not staying with your hands on the keyboard and keep working on stuff, you're probably not going to stay sharp enough to be useful as an engineer. You may be able to still do systems administration. You could probably hang out in the systems administration world for a long time. This is actually something Fisherman mentioned yesterday when he came and talked to our group. And he gave his stuff is in the chat down here. His stuff, he actually posted, if you guys didn't know, he posted his thing down here of what he talked about. So if you guys missed it, here's his stuff. But one of the things he pointed out, he's like, hey, you could sit in a role and not grow at all. There's a lot of roles out there where you first get in and you work in like a network operations or like a help desk. I'm not going to say anything bad about like my wife because it'll get me killed. But my wife has been a help desk person the entire time I've known her, which is 21 years now. She just never wanted to move out of help desk. And she's about to retire from the school district that she works for. She retires in about 5 years. She's got a countdown going. She gets to retire with full benefits in her early 50s, and it's going to be nice for her. And it's like, but she just never wanted to move into any other role. And you can do that. You can do that comfortably. She's very good at the simple, low-level stuff that she does. And there's nothing wrong with that. That's what she wanted to do. That's what she does. And that's something that Fisherman mentioned yesterday. Like, you could do that. You could just get in, and you could just be out. He even talked about this, like, the 80-20 rule. Like, a lot of people are just going to, they got their job, and they're just going to go drink their beer on the weekends and watch their sports, and there's nothing wrong with that either. But if you're not going to also try to make yourself any better, that may be as far as you go in your tech career. Yeah, well, too big to fail. A lot of people are finding out with, man, the last few years of tech, I've been watching just jobs get slayed on LinkedIn. Like, I have a fair amount of people on LinkedIn that have connected to me because my college students over the years and other people. And it's like, I've seen really, we have a really, probably one of the most talented engineers I've ever worked with in our Discord who got laid off in the last few months. If I talk to anybody, like if anybody in that company ever asked me anything about like what was the biggest mistake we made, like on the engineering side of things, I'd have said letting that guy go. I wouldn't even have questioned. I wouldn't even have asked. I wouldn't have talked about anything of their financials. I would have said letting that dude go, because that dude's gonna run companies one day. He's one of our engineers, and he's really good at what he does, right? But that being said, other people just they don't care. Now, there's places you can go sit. You can go sit in school districts. You can go sit in government positions and never get any better at your craft. But I would tell you that's not what most engineers are willing to do. I would not. If you paid me double what I make right now, right? If you paid me double to just go dig holes out in the field and then fill those holes in over and over again, I wouldn't do it. There's no job satisfaction. There's no life. And you might say, Scott, if I made double what you make, I would definitely do that. And I say, yeah, you wouldn't do that for very long, man. I'll tell you what, like they've proven it. They've given people more and more money, and people will walk away from jobs like that. They can't do it. It's not satisfying, right? And look, there is probably a certain initial number of people who would do that, but I'm saying over time you wouldn't be able to do that. What field paid me the most? Definitely engineering. Systems engineering pays me the most. Teaching doesn't pay me hardly anything. This doesn't really pay me anything. Like, I don't really make anything doing streaming. This is like a pittance, and it just kind of goes back into getting the public speakers, like our speakers that come in, like Fisherman and other guys. I'm always just like giving them little, $50 gift cards and stuff like that. But like, I don't make anything doing this. Engineering pays a lot. Engineering is definitely the way to go. As far as you can make, good salary, you can do very well and that kind of stuff. So, all right. So here's my quotes to get you interested, or to the point. We're engineers. We deal in truth. Our utility, or what's called the value added by a function of some process, to a company is directly related to what we know and how quickly we can get to the right answer. So that's why companies keep us around. What do we know? How quickly can we get to the right answer about stuff? That's what you're going to be measured with as an engineer. I also tell you that as engineers, you will be judged by how well you can write emails. That's always going to be true. If you are the smartest engineer around, but you're typing stuff like, I like cookies, and it's like lowercase I, like is spelled wrong, and it's L-I-E-K or something, you're going to have a hard time. All right, but anyways, what are we sometimes called to do? We are called to figure out what's the best technology for some random problem that the company has, or fix something that's already there. Those are our two things. Deploy new technologies, fix working current technologies. Those are the two things right here. If we were to kind of squeeze this down and distill it down. And then to that point, if we understand that truth is what we deal in, and we need to be ready with technology, how do we keep ourselves valuable for businesses and customers? Like if we're, selling our services to people, we want to get into like consulting. How do we get ourselves ready to do that stuff for customers and people that want to do that? All right. So here's our overview. Learning how you learn, certifications, home lab. There's professional projects you can do. There's personal projects. I think you should have a book collection. You can find books online. You can buy them off a Humble Bundle. And then maybe the most important thing you can do is find discussion groups, podcasts, blogs, open source community. You guys could hang up. You guys could get off of this. You could close down the tab you're in, and you could go start coding and open source stuff right now if you wanted to. I would maybe spend some time looking at the different open source options you have, because maybe you get involved with something that's not really going anywhere or not very popular. So there's stuff like that. But generally, there's projects for you to go work on right now. There are people that need other capable people out there doing stuff. And then mentor others. If you find yourself, you're the expert in your organization and nobody can challenge you for being the best engineer, start to mentor the others. And mentor them in such a way that you get them to a level where they push you off the top of the pile, and then you can go and retire off into the sunset, right? So there you go. All right. So one, I think you should learn how you learn, right? Everybody is going to learn differently. Everybody is going to focus on different things. But this is a general high level thing that I think you need to kind of take stock in. Like I tell people, like, I don't, obviously people come to Twitch, and I think YouTube is more about people wanting to learn stuff, if we're being honest. I think Twitch is more about being entertained. And I get that. Like, the most popular people that are doing tech on Twitch are not teaching you anything. They are infotainment. They are giving some info, but they are entertaining you. They are entertainment, right? But I call it infotainment because they're throwing out some info, and sometimes they have some background to what they're talking about. But for the most part, the people that are popular on here aren't trying to teach you anything. So if you spend 8 hours a day in some of their streams, that's cool, you know. But just know that that's not your study time. And if you're calling that your study time, there's probably, you know, you're probably wondering why you're not learning anything the last couple of years of doing that. So that's fair. I see that's fair. I think of Twitch, so I'm a little bit older than probably most of you. Twitch for me seems like when people used to do a lot of commuting back in the day, you know, spending an hour in their car, and they would listen to like shock jocks on the radio. And by the way, if you say, well, what do you mean by that? The most popular people on Twitch in general aren't teaching you anything, right? And that's fine. It's an entertainment site, right? People are here to be entertained. But I'm just saying, understand that watching Twitch in general, even people that are in the like, because I'm in science and technology, I don't do that software and game development stuff. Those guys are there to infotain people. They're not there to actually show you how to do something or understand a thing, right? For the most part. And I think of them more as like a radio show program in the morning, and that's fine, right? That is what it is. But this is what I think you should do to learn. There's no anyways, my point in that is there's no difference watching that than going to like watching Hulu or Netflix or Crunchyroll or whatever your fun thing is. And Lezerbisca, hopefully this stuff's useful to you. Thanks for the subscription. That means that, you know, you don't get ads for a month, which is always cool. But you got to figure out what schedule works best for you. I know people who, like, I pop out of bed at 4:20 in the morning, take a shower, I go to wrestle. That doesn't bug me one bit. But I know people who wake up in the morning and they are just dragging. And that's, if they don't have their coffee, they're not even awake until 9 a.m., right? I know people like that. But those guys can stay up late. I can't stay up past like 10:30, 11 anymore. I'm dead, right? Like that kills me. So I can do that, but I understand that about me. So what schedule works best for me? I try to study all throughout the day. That works for me well. Do you need a Pomodoro timer? As an engineer, I have extremely hard. I have really bad focus problems. I always have my whole life. In fact, I had a psychiatrist once tell me that he would diagnose me with ADHD if I wanted, and I'm like, I don't really need it, but it's fun to know that you think I have it. So a Pomodoro can keep you on task. If you don't know what on track or task, but if you don't know what a Pomodoro timer is, it's like a 40-20 or a 45-15 or a 50-10, and what it is it is a timer that like gives you time to do focus work, and then time to sit back and think and like relax and go take a walk around your upstairs or whatever, or go, you know, pet your dog and get yourself a drink. But Pomodoro is about focus time and relaxation time, because this is like people might think, oh, sitting at a desk all day isn't hard work. Look, I was a roofer in Phoenix when I was a teenager. My uncle owned a roofing company, so I did roofing in Phoenix, and I was an infantryman who deployed to Iraq in 2003. I can assure you I have done two of the most physically demanding jobs around, ever. It is a different type of tired to do stuff with your mind all day. In fact, I tell people, like, when I have to patch all day, if I have like an 18-hour day of like patching servers, the amount of focus I put into that, I'm done later. Like, I'm just ready to just pass out and not think about anything, because you're so focused on stuff, right? And learning is focus time. You have to focus on things, so it's hard to do. So a lot of people, and I'm guilty of this too, we veg out and just sit around and watch Hulu or something, right? Watch something on the internet. But I would ask you this: can you sit and watch videos for hours? Can you do a task while something's running in the side? Not everybody can do that. Some people can. I can watch videos on YouTube over to the side on like AWS stuff, and I don't catch everything. But they're just sitting up there, and then when I need to, I'll be like, oh, that's kind of cool, and I'll focus in on it, stop doing what I'm doing, give them a few minutes. But can you watch videos for hours? Not everybody can watch videos. Not everybody can sit down and read. Some people are just like, I can't read another word ever since high school. I know people, I have a cousin who, one of the things he likes to tell people is, I've never read a book my entire life. That's one of his favorite things to tell people. He's never finished a book in his entire life. He started some. He's read some excerpts in high school and stuff, but not much. But his favorite thing to tell people is that he's never read a whole book. Yeah, so some people are very visual, right? This is another one. You do not find time, you make time. So if you were one of those guys that can pop up out of bed in the morning and you can study for 10, 15 minutes before you start your day at work, you got to start doing that. This is the same thing with like writers. People ask, like that dude George R.R. Martin who wrote the I never watched any of it, but the Game of Thrones stuff. One of the most popular writers, Robert Jordan, who died a few years back, early 2010-ish or 2011, I think he died. And then remember Brandon Sanderson finished The Wheel of Time for him. Anyways, those two guys, people ask them, how did you write so much? They've got these books that are like this thick, each book, all down. Like I could have my whole wall back there of just Robert Jordan books, right? How did you write so much? And they're like, all I did was sit down and write a lot. Like, how much did you write today? And if it's less than 3,000 words, you don't want to be a writer, right? That was their idea. Well, I'm the same way. You do not find time, you make time. And then this is true of the gym. If you guys know anybody that goes to the gym, a little daily, even if they feel like shit at the end of the day, your friend that goes to the gym still goes to the gym. And the reason they do that is because a little daily is better than cramming in once a week. Just going to the gym on a Sunday and lifting weights for 4 hours is not nearly as good. And look, I'm not even a medical doctor, but I can tell you every sports physiologist guy out there is going to tell you this. A little daily, 30 minutes a day of walking is better than 4 hours of walking on a Sunday. What's probably better is to walk all week and then do a big walk like that, like hiking or something. But the point is, a little daily is better than cramming once a week. That's true of your mind. So figure out what you're interested in. Take a self-assessment on what you're interested. We have one free in Discord. Do you guys want to see our little self-assessment? Again, free stuff. All our stuff's free on Discord. Hold on, let me go get our self-assessment. This is in the Prologue self-assessment matrix. So, look, this is not prescriptive. I'm not telling you have to do something a certain way, but this is kind of how it looks like to do a self-assessment. You come in and you say, well, what do I want to do? I want to determine my skills and my skill gaps. What am I interested in, and what do I want to do? The scope is we want to find out what our technical skills are and our technical interests, and then we want to find out what our business skills are and our business interests. I originally did this for, we were going to have self-assessments within an engineering team that I had helped build for a college, and they came to me and they said, hey, we have this normal like process, but could you help us to build like a training plan? And I did a whole training plan for that college as well. On their high-performance compute stuff and things that people should study. But what's in scope and what's out of scope? What's our methodology? How are we going to objectify this so that it is objectively, I know it's not the right term, it is technically the right term, but objectively determine the skills that we want as opposed to subjective, right? Like, because you can come around later and be like, I don't really like that stuff where I do, but what if you just sat down and just mapped out what you actually want to do, right? That's a better thing. There's this old, Lewis Carroll wrote the Alice in Wonderland. Some of you guys are familiar with it, but most of you know who the Cheshire Cat is. And he very famously, Alice asked him, which road should I take? And he goes, well, where do you want to go? And she goes, I don't know, anywhere. And he goes, well, then any road will take you there. And if you don't, my point in that is if you don't sit down and figure out where you want to go, you're going to do a whole lot of coddywamples, right? And you guys, if you've been around, you know what a coddywample is, but it's a way that you walk assertively towards a vague destination, right? You act like you're doing something, but you're never going towards a goal. So this is a way to find a goal, right? So we come down here, technical, and you could put any other words you want in here. This just happened to be for my Linux guys. Linux, storage, security, networking, Git, automation, monitoring, database, cloud, Kubernetes. And I put Git in here because most people do know what SVN is, I think, but it's just software versioning, right? What does that stand for? But software versioning, right? SVN. And then Git is the most popular one. So anyways, you assign how well you know any of these things. And look, if you do this and you're not honest with yourself and you just put tens down the board, all right, well, you're an expert. I got nothing to help you with. I have nothing to help an expert. I still need to work on some things, right? But, if you're honest with yourself and you find what you do lack in, that's a good start. But the next one is maybe the more important one. What do you want to do? Because if you tell me you're like a 3 on Linux, But then you get down here to your interests and your Linux is like a 0 because you're just like, I don't want to do any fucking Linux. But I really like storage stuff. I really like putting disks in racks and making sure that storage arrays are good. Did you guys know there's jobs all over the place? I can go to DICE right now and find a bunch of jobs on storage engineers and storage sales personnel, pre-sales engineers, and that kind of stuff. And you might have to study and spend some time, but the point is, if storage is real interesting to you, it's good to know that. Maybe one of the most important things you could do is sit down and figure out, what do I really like doing? Like, I found out early on, like, because I've coded enough over my lifetime. I had a really good Java professor in college. You say, how good was your Java professor? My Java professor in college published a book that was used by 180 colleges to teach people Java. So I'd say he was probably pretty good at Java, right? At least good at selling books on Java to colleges to teach people Java. And I thought I learned Java very well from this professor. Not JavaScript, Java, right? Basic Java. But you know what? I did the class, I did the pseudocode, I wrote out the flowcharts, and I understood it. And then I went, I don't really love this. I don't want to do this for the rest of my career. Could I probably, like, take that pill and then swallow it every morning with some water and work through being a software engineer? Maybe. I don't know, maybe I'm smart enough to do that. But I'll tell you right now, I would hate my life every damn day while I did it. And that's not interesting to me. But getting in here and building systems and messing around with, mucking about with systems in my home lab, this is interesting to me. And I do this stuff for fun even when I'm not working. I tell you guys all the time, I can't believe people pay me to do what I do, and they pay me as much as they do to do this stuff that I would be doing for fun. Now, don't tell my boss if you ever talk to him that I do this stuff for free, but because he's paying me a lot. But yeah, so find what's interesting to you, right? Some of you guys, I'll tell you guys right now, this is an honest one. I know some database guys, and I look at them, and they're good friends of mine, and I'm just like, man, I could not do what you do all day. I couldn't do it. I would not be. I couldn't do database stuff. Like, I'm not saying I couldn't technically do it. I'm saying I hate it. I hate maintaining. By the way, some of you think that database work is just like writing some SQL commands every now and then. No, database people are doing backups and transforms, and they're looking at the database security, and their database engineers are a tremendously interesting field for people that want to do database. And they're doing the different normalizations against databases that are given to them by the application teams, and then they're working on those databases to make them more efficient while not breaking the structure of the app that's coming into them. Tremendously interesting work for people that want to do that. I am not one of those guys. I looked at databases in college and I was like, oh, okay, yeah, okay. In fact, when I'm teaching, I teach on Thursday nights at the college. The guy in the room behind me, Professor Rick Bird, he is always teaching the students on databases, and I hear it sometimes, and I go over and close my door. So Crispy, that's what the self-assessment is. It's for you to come in and start to assess what you actually like to do, right? You got to go start practicing it. So let's say cloud. You want to see if you like cloud, because everybody tells you cloud is good money, right? Cloud's good money. Well, I'm just going to go to AWS free online training. Did you know AWS has all kinds of free training? And when I say all kinds, I mean like hundreds of hours of free training. Some of you guys that know, when I got my Solutions Architect Pro in AWS, well, let me back up a second. I got my Certified Cloud Practitioner a few years back. Then 5 days later, I got my Solutions Architect Associate. And then a month later, I got my Security Cert, right? And all of that I did for about 17 cents in the cloud. Like nothing, like, yeah, I have all kinds of certs in the cloud. Like, it's silliness. And I think it's great. But did you guys know that, like, you could go and deploy these things and build these things for nothing? I spent like 17 cents in the cloud. It might have been like 78 cents. I forget. But look, I want to start with Cloud Practitioner. They don't give the cert. No, I spent a lot of money on the certs, but I mainly did that. Look at this. Free digital stuff. 6 hours, 12 hours, 12 hours, no fixed duration. All this stuff. Oh, Cloud Quest is a big one. People really like Cloud Quest is like Grand Theft Auto, but instead of having guns, you have cloud shit to go do. But you could go drop in. I could go sit in here and play with this right now. Yeah, they have a game. It's called Cloud Quest. Yeah, and then this thing, is this one still free? Yeah, and then you just walk around and do stupid cloud stuff. So my point is, maybe you find stuff that's interesting to you, stuff that you want to do, and then you play this for a little bit, and you're like, all right, that's cute, there's Big Dog, and you go do some cloud stuff, and then you go, you know what? I'm going to leave cloud for the other guys. because cloud at the end of the day is a lot of API calls and a lot of structured and semi-structured language building from templates and environments, and then we deploy stuff, then we get errors and we back it off and we figure out where errors are and we redeploy it. But cloud in general is maybe not that interesting to people. I'm not super interested in it. I did a lot of it for kind of fun, but man, look at all this. This is all free. Hours and hours, maybe 100 hours worth of free stuff here, right? And Azure, Microsoft has a whole bunch of free stuff too. When I did their AZ900, I didn't deploy a when I passed my AZ900 for AWS, I deployed nothing to Azure rather. When I got my AZ900 in Azure, I didn't deploy a single thing to Azure. Didn't deploy a single thing. I had done it for my college and stuff where I teach and stuff, but my AZ900 I passed without doing a single bit of business with them. I just went and read all the stuff, right? So like cloud's okay, right? Well, with Linux admin, I would build a Linux server, right? Like you can just open up, look, Oracle VirtualBox. I don't even know why I have Oracle VirtualBox on my machine, but I do. And not everybody's going to go like me and have a whole bunch of systems out there, right? I have a whole bunch of systems sitting in a half rack behind me. But you can come here, and I built this like messing around the other day, and on stream actually. And I'm going to double click this and power this box on, right? I'm going to power this server on. I don't think I ever even built anything on it. But now this is going to be running inside of my machine. Hold on. Select a virtual disk, cancel. Let's just go move this over here so you guys can see. All right, I got this Oracle VirtualBox up. Do I have an ISO for him? A fatal, bootable, no system. Let's mount on him an ISO. I'm pretty sure I have some ISOs out here. Oh, I definitely have some ISOs actually now that I think about it. Hold on. So let's go, let's look at this machine real quick. His input, devices. Let's go to his optical drive. And he's got an optical drive. Oh, he's got Kali. Let's pick Kali as his ability to boot from. That's an ISO I have in my network. So now his optical device is Kali, right? Right? And then we're going to reboot this machine. So we're going to reset him and bring him back up. And then we're going to build a little Linux box real quick. And then we're going to watch system boot. We're going to watch it install. And then we're going to look at it and go, nah, I don't want to do that either. Right? Now, here we go. Graphical installation of Kali. Let's just say, oops, install. Graphical install. Nezor said, what are the jobs are cloud looking at Linux? 90% of jobs specs are either DevOps or AWS. HPC networking feels like it's standard to do cloud. What do you think? But I think there's a lot more cloud coming, Nezor. But also, there's been a push recently to move out of the cloud, so not everybody's doing cloud anymore either. Like companies are always, there's this weird thing that happens all the time in systems. It's almost like waves crashing on a shore. Like you guys know, like the moon pulls the tides. You guys know how that works. Some of you are probably familiar with that. But there's always tides. There's always waves coming in. And in the business world, especially around computers, there's always this push to have everything centralized around big, powerful, high-performance compute systems, or centralized mainframe, or you know, and then we're like, oh no, we can go to distributed. So we go out to distributed and cloud and running stuff on people's desktops when they're not around, and then we go, no, we don't like that, there's too many errors, and then we move back. So there's like this ebb of flow in technology all the time of like aggregate everything up into big, powerful, single like instance type devices, and then all the way back out to distributed. And it's just it's a weird like thing to watch. Yeah, hybrid's the hottest because hybrid is easy to deploy. You still have control of some things. My company, Redline, there's reports out there. Redline did a report a while back. Well, I'm just going to turn this machine off. We're not going to build them right now, but the point is we could build them if we wanted to, right? My company, Redline, who I work for, and shoot, hold on. We did a study back in 2021, I think we released it. Let me go find it. Hold on. Redline Perf, right? And if we go to case studies, we were doing production supercomputing, and we were looking at doing it up into the cloud, right? And we were using Azure because that was kind of the challenge that came at us from the government. And we tried to put it up into Azure to prove whether or not it was of value to go this route. Ragnarok said, I've found this channel in recommendations. I always felt like I really lack in DevOps, so this channel was a good find. Yeah, Well, hopefully this stuff's useful to you, Ragnaroks. I don't always talk DevOps, but I do have quite a bit of Kubernetes experience and that kind of stuff. But down in our Discord, there's a fair amount of people that know a lot of other stuff too. Hold on, let me give you guys the Discord if anybody wants to go hang out in there. And then I'll link for you YouTube guys. There's our Discord link. If anybody needs our Discord link, there you go. I messed it up, but there you go. All right. And then what do we do on this one? This one was, that was production supercomputing. Hold on, let me see if I find, I think we were doing, yeah, we wanted to see, this one was a challenge to basically every 6 hours, NOAA, which is National Oceanographic Atmospheric Agency, of whom I still have a CAC card for them. I still work for them, or well, I work for them when they need me. And we wanted to see, doing their workload up in Azure cloud, what would be the costs and what would be the worth of that, right? And do I have, we used to have this published. But anyways, we found that, I don't know where they have this. They have this somewhere. I get access to it if somebody needs it. I'll post it up in the Discord. But the point was, it was still more cost effective to run a big supercomputer in a data center for them than to do the workloads up in the cloud. Even with the downtime in between runs, and even with the stand up and the turn off and all that stuff, it was still a better deal for them in the long run to do it in their own data center and with their own systems. So, all right. Yeah. So anyways, there's that. But we were talking here. We were talking specifically about what are you interested in doing? And then I gave a little bit of business stuff. This is business, like time management, public speaking. Some of you wouldn't get caught dead in front of a group of people. Some of you, public speaking is not your thing. But there's ways, if you're interested in it, there's ways to get better at it, right? Managing others, budgeting, financials, vendor interactions. How well do you deal with a bunch of different vendors trying to sell you stuff and trying to get support from those vendors for products you've already bought? How well do you kind of manage your vendor interactions? Because that's a business skill. It's a business skill that does not exist in a lot of engineers. Me, I can do some of these things. Like I do public speaking, but do you guys know that I actually prefer to just be left alone? You guys might think, oh, Scott wants to get on Slack and talk to people all day. Well, oh, hell no. I don't want to talk to nobody. I just want to be in my servers all day doing whatever I'm building, and then I want to get out of there. I don't want to be talking to other people, but I can do it. And mainly, the main reason I can do public speaking is because I was in Toastmasters when I was in high school. Toastmasters is hands down the best thing you can do if you want to talk in front of people. Hands down. There's not even anything close to it. I wouldn't tell you to do anything else close. Like, most of you somewhere in your area can find a Toastmasters group. And some of you, I don't know if you've ever thought about doing it, but one of the first things they'll do is they'll have you watch a meeting, and then they'll have you give a talk. And one of the things, there'll be a little person sitting in the corner with a bell. They'll have a little bell. I don't know if any of you guys ever heard this. They probably even have Zoom meeting. I bet they have Zoom meeting Toastmasters nowadays. I'd be willing to bet. But what happens is you sit there and you go, well, and ring. So ring. Every time you do a vocalized pause as you speak, as you're trying to think and you go, people will ring a bell. And it'll be really, really annoying. But they will drill out of you the repetition as you talk of doing vocalized pauses. That kind of stuff doesn't fly in Toastmasters. They will ring a bell and they will teach you, they will train it out of you like Pavlov in reverse to not use vocalized pauses. And it will make your public speaking better. I'm gonna tell you guys a story. This is like I should pull this guy up sometime. And this is not political, and I am not talking about Barack Obama. I am not talking about any politics. I am just gonna tell you that there was a guy who worked for Barack Obama. He was his second press secretary. I forget his name. I can find him if you guys want. I want to say he was like, gosh, just before 2012, right before he got elected. And this guy, I would watch him and I would go, I don't know how this guy ever got into public speaking. This guy would as he tried to, that's what he fucking sounded like the entire press conference. And I'm like, I don't know how anybody didn't just go, dude, can we get somebody out here who can actually speak? Because this guy would do 2 to 3 vocalized pauses for every word he would say. And you might say, Scott, you're being overly critical of a guy. One, I'm not being political. I'm just talking about this guy's job. And 2, I wouldn't be that critical of like a high school student being that nervous because he's been a high school student and he's nervous or whatever. But I would be very critical of a person whose job is literally public speaking doing that. Because I'm telling you right now, if he had had 2 days of Toastmasters, they would ring that bell so much that they would have broken a bell and had to go to a new bell quite a few times with how many times that you can do it. Now, again, I'm not trying to be political here, but there's a way to do vocalized pauses that are very good. And, whether you like the guy or not, the guy who I know who was a very good public speaker who did vocalize pauses, but it never bothered anybody because he did them well, was Obama. Go watch some of his speeches. He loved to do uhs and ums as he talked, but he kind of had a method of doing it that worked well. And I had to admit, like, from a public speaking standpoint, the guy was great. Whether you like him or not politically, that's something else, and I'm not trying to go there. But I'm saying, like, you can look at how people talk and say, well, this guy's a professional public speaker. He is a press secretary, and the guy was absolutely the worst thing ever. And a lot of people are bad at public speaking. Do you guys know that there's people who would rather, like, stand on the edge of a building and look over than do public speaking? Or there's people who would rather be naked in public than do public speaking? They've done studies. Public speaking is more scary to some people than a gunfight. And I've done both, right? I was an infantry guy in Iraq, so like I'm a combat infantryman. But like I'll tell you, I know people who would still rather go back there than do public speaking. But you can learn how to do this kind of stuff, right? So Exonium, I could run Toastmasters. I was a Toastmaster. I've done all the speeches. I know all the things. I just never thought to do it in the Discord. I think people would probably learn well from it. And I think people would probably, it would be good to put on a resume that you've done some Toastmasters. So, yeah. So, anyway, so then we come down, we find what we want, and then I think you should do a SWOT analysis. SWOT analysis, normally, we're doing our Prolog self-assessment matrix. Normally, a SWOT analysis is for a business. This is not something that a person does internally to themselves, but I'm still going to give you it as a practice, thing to do. But internally, you do strengths and weaknesses. Those are typically internal to yourself. And then external is outside of your control most of the time, opportunities and threats. So it's strengths, weaknesses, opportunities, and threats. Strengths and weaknesses tend to be within yourself. And again, you're not doing this for me. You're not like doing this to turn into the Discord and then we're going to write you up and go, you should be a level 3 systems engineer because that's what's good for you. No. This is for you. This is for you to... I was talking about earlier, any road will take you there if you don't know where you want to go. So, you go from not having a plan to finding out what you want to do and starting to figure out what you're good. If one of your weaknesses is time management because you're terrible at it, okay. We could figure out time management. We could do Pomodoro. We can do a little timer that rings every 15 minutes and tells you to get back on task. We could do all kinds of things, but you don't have to just sit in that weakness forever and never get to whatever kind of goals you guys are trying to work for. All right. So SWOT analysis looks like this. What are my strengths? What are my weaknesses? What are my opportunities? And what are my threats? So I come down here. Oh, I don't have the one. I thought I wrote this up. I thought I had one that had an example and that had some funny stuff. But so learning how you learn. This is from our excelling in the engineering field talk, and that's what we were doing originally. So, all right. Here's what we're going to do. Take a little break. I'm going to play some more Brotato. You guys can keep asking me questions if you want. I'm going to... Oh, that's a good one. I'm going to play some more Brotato while I kind of hang out. Do I have a piggy bank? Good. Okay. So if you have questions about any of that stuff, let me know. If you guys want to know more about the Discord or the Linux Systems Administration course that we're running, those are all free things. In fact, the only thing around here that costs anything is the book. Everything else around here is free. And the book is not required for the Linux System Administration course. I've been asked that quite a bit, like, oh, do I have to buy the book to do the course? No, you do not. But even then, even if you did, I think $20 for a book is pretty cheap compared to what you get for that Systems Administration course. Again, completely free. So, all right, let me get this round done, and then I'll go back to reading chat if anybody's got any questions or anything. So, all right. Do most people who haven't heard their voice as it hit an outside ear. Why are people freaked out listening to their voice recording? Shunyam, I don't know. I actually dislike hearing my own voice. Me and my brother Tommy sound very much alike. Some of you guys have heard my brother Tommy talk before because he came to the he came and talked at the professional Linux users group in our, what is that called, in our 5-year anniversary. He came and talked that. Your Farm, I missed the beginning. Do you have presentation in Discord or anywhere else? Yeah, Your Farm. This presentation is up in Discord. This is called Excelling in the Engineering Field. And earlier, guys, we did the Unit 4 recording, so I got that all done, and then I got out of there. But I want to say this is in presentations, and this is right... Oh, there's the one earlier, the Why Engineering, if anybody needs that one. This one is up. Socratic Linux, Twitch. Yeah, this is called Excelling in the Engineering Field right here. So that's it right there. Yeah, I don't necessarily like the sound of my own voice either, but I sound a lot like my brother Tommy. I know that. So, and it's funny. I actually was surprised nobody caught it when we did the group. I want to say, like, for the first one, we had about 40 people in August, and then all the other talks we had probably averaged 24 to 35 people or so. So. All right, that's weird. I'm getting calls from people. Well, so my solution to not being used to hearing my own voice is I don't ever listen to any of my recordings of anything. But yeah, this is up in the Discord if anybody needs it. Let's get back to, I'm gonna finish this round of Brotato. Those things are all good. I'm gonna store my piggy bank. I'm gonna start saving. I'm gonna bank some money for a little bit. And the reason you bank money is because you get interest with the piggy bank. And you can actually have a pretty good run if you save a fair amount. But you also have to balance that against getting more powerful because the levels get harder, right? Let's see if we can get through. A little bit of Brotato in. Oh, we want to kill that guy because he always drops a loot crate. And the little loot crates are items at the end of the level, so that's always useful. We're going to let those guys drag through our turrets so that the turrets kill them. And then we only have a few seconds left, so all we got to do is stay alive for a few seconds. And grab all the loot. That's all experience in gold, in case you guys are wondering. Alright, scope doesn't matter for this guy. Range does. Elemental damage, and we'll take engineering. That's fine. So... the ice cube is good, but we'll take the snowball first, and then that, and then that, and then we'll save our money for... Typically, we want to try to save up and get like over 500, so we actually get a good amount of interest each level, but... let's see how we do. Alright, when those guys get that little glow around them, they're just taking extra damage for the next few seconds. That's all that does. It's just a damage, what would you call that? It's just a damage modifier to the character. So, makes me hit them harder. Alright. I'm going to look that guy up later and I'm going to post him in Discord so you guys can see what I mean about somebody who literally says or every other word, and then once somebody showed it to you, you won't be able to listen to the guy anymore. You'll be like, I can't believe that guy was a professional public speaker. This is one of the best items for this guy because basically I'll just keep getting more and more turrets and they'll take over the screen. And I'll save this stuff, but again, I'm trying to save money for future levels, because I'll keep getting, basically you can snowball and get really high amounts of money if you save just a little bit early on. So that's what we're going to start doing and try to kill all these guys off. I want to find some trees because that'll give me more of these little turrets. So we need trees. Trees will start with yellow X's and then we'll get little blue X's when they turn into those things. So really all we got to do is keep killing enemies and collecting loots. Alright. Right, and every tree we kill turns into another turret. So, it's very useful on levels like this where there's a lot of really weak enemies. Because those turrets don't do a lot of damage, but they can kill those weak enemies one hit. So that's kind of a kind of a useful thing. Unfortunately, they don't, since they're not permanent structures, they don't add to my overall damage with this character. This character gets more and more. Yeah. All right, we're gonna take elemental, and then we're gonna just hold on. We're just gonna, because watch, that 605 coins that I have is gonna turn into 726. So we're actually gonna save just for another couple levels if we can. If we can just survive, we can start getting a whole lot of interest. So a big part of surviving is going to be getting more of these turrets everywhere. And we're almost to 1,000 gold, so that's pretty good. All right, stay alive, guys. That's the goal. It's always the rule. Stay alive. On top of everything else, just stay going. All right, hold on. Just had something weird happen in my system for a second there. Had my other monitor reset. That was that was weird. Yeah, this monitor up here reset on me. I don't know what it was doing. The monitor that shows my connections out. So, all right. Anyways, that's good. That's enough of that. But play more Brotato on my own time. But learning how you learn, very important. And then this is a thing. This comes from what's called Bloom's taxonomy. This is the idea that this is how you start to learn things. One of the reasons some of you guys in the systems administration course might be like, Scott, why the hell are you making us just learn? Like, one of the things I'm making you do is like go and look up terms. And the reason terminology is so important is because the way engineers talk about things, and if you look at any career field, the way things happen, the way people talk about phenomenon, and the way people talk about, like, let's say this is a phone, but it's also a communication device, but it's also an IR receiver. And maybe common to, a certain field, this might be called, I don't know, this might be called the token box or something. I don't know. There's all kinds of things. So you're starting to learn the terminology and the technical terms for things, and the, just the way that people talk about things, right? So we learn by understanding at first facts. Just recall basic facts. In a Linux server, there's a kernel, and the kernel interacts with all the other components, and the kernel is what has the ability to allow a process to reach down to a kernel, the processor. It can also give access to memory locations, and the kernel is kind of the train station of all other things that are happening in the system. And then you load modules that allow things to interact with the kernel. Okay, what the heck's a module? A module is a function of code that interacts with the kernel to allow certain things happen certain ways. Modules load into the kernel, and then there's drivers, and drivers are loaded so that certain hardware can be interacted with, right? And then processes can load the drivers to move the hardware or do whatever they need to, or move data. There's all these things, right? And that's just, again, at the beginning, that's just remembering and understanding stuff. You're not actually doing anything with it, or analyzing how well it works, or evaluating the components and then creating new ones. You're not doing any of this stuff. You're just remembering stuff and spitting it back at me, right? What's your opinion on Red Hat certs? I think Red Hat certs are great. Currently, I have an RHCSA, RHC, and troubleshooting, but are kind of useless a bit and does not have any value for my wage or any other job opportunities. I'd say both. Make sure you're just keep looking around. There's a lot of remote work, but RHCSA and RHCE are very valuable. Can I ask, are you in the U.S. or outside of the U.S.? Because in the U.S., those things matter a lot for government contracts. If a government contract requires a company to have 40 RHCEs on a task, I don't know how well it's going to work for you in the EU, but I have to imagine there's probably EU jobs, like jobs in Europe, that are based on having those certs. Because in the US, it's like that. If you get a contract with a company and you have to have 40 RHCEs, and that 40th RHCE doesn't do shit for the company, you still can't fire him. You need him there for that contract to remain valid. And I watched that happen. I used to work for a company called CGI, and there were guys there with their RHCEs that didn't know anything. I mean, they knew enough to get an RHCE, but they didn't do anything. They didn't help anything get better. So that's something to think about, right? that company, CGI, is a Canadian company that does a lot of government stuff. Yeah. Does a lot of stuff down in the U.S. Have you ever heard of Linux admin? Wait, oh, that's actually weird. Nick, one of your things only popped up over there. It didn't pop up down here. Oh, no, it did pop up here. Have I ever heard of Linux admins or engineers topping 250K? Yes. Yep. Yeah. That's not impossible. Engineers are typically going to be topping 250K. Yeah. Admins, so you guys got to remember, admins don't make as much typically because admins are a lower function of what becomes engineering, right? Some of you guys have seen me talk about this before, right? Admins are over here doing operating and optimizing of systems, but engineers are over here doing the prepare, plan, design, and implement. So PPDIOO, which is an old Cisco term, but preparing, planning, designing, and implementing things are engineering work, and optimizing and operating things are administrative type work. So that's kind of a thing. I have a bunch on this. This is my sysadmin page, right? Like this is sysadmins type work. Getting into Linux, troubleshooting, your questions, Linux skills, general knowledge, structured learning, learning how you learn, unstructured learning, all of these things. I have a whole bunch of these, right? Anyway, there's a whole bunch of those. But normally I'm just showing you guys this because this is the thing I reference. Maybe not the most, but I reference this pretty often right here, the PPDIOO methodology. Yeah, SREs can make that. Yeah, DevOps guy. Yeah, there's I'd say it's all consummate with your amount of experience and what you kind of know about a system. Yeah. Yeah. I'm a Linux systems engineer. That's what I do. But I work in high performance compute engineering. So I work in a lot of very niche high performance compute stuff that is very valuable to people. Like the tools I use, like Slurm and Werewolf and some of these other Bright clusters, like they actually make me more valuable because those are the things that, and I work in big data, Lustre and Weka now. I've been using a lot of Weka lately, which is kind of this new thing. And my company, we subcontract to like Google. I'm sure we work with Google, but Dell. So Dell will go and win contracts, and then my company will come in and build a lot of the stuff. So Fedora or Debian? I mean, depends what you want to do, Nick. I would tell you you're going to probably move a little farther on the getting the job side of things if you're focusing on your Red Hat type stuff for sure. So Debian, Ubuntu, those kind of things are now not Debian itself, but Ubuntu is a government, U.S. government can run Ubuntu systems now. So yeah, Ragnarok's, and one of my skill sets I picked up early on is I've been working in a data center since the beginning. So I can do everything from racking and stacking, and I can build racks, I can put stuff up and down, I can do your power, space, and cooling, I can do all that stuff. So I have a talk on here. Actually, I have a talk on the YouTube side that's just high performance compute stuff for you guys. So some of you guys have been around for that, and we've talked through that. We're talking about excelling in the engineering field after college and stuff like that. Racking and stacking is definitely fun when I do it like once a year. I still go and build, like I was just in a data center in Austin a few weeks ago. Some of you guys remember that. Well, we're starting week 6 of my college, so it was week 1. Yeah, it was week 1, so it was 5 weeks ago. I was in Austin for a week. Some of you guys remember that. Please link it in chat. Are you talking about the HPC stuff? Yeah, my HPC presentation is, excuse me. My high performance compute topics is right here. It's from July of last year. But the actual, hold on, I'll find you the AWS or the YouTube. Hold on, I gotta find my YouTube. I gotta put this over my thing real quick. Hold on. YouTube Studio, or I guess I could just view my channel. Hold on. Content. So if we go look at my little YouTube thing, right? And it's right here. By the way, there's some really good stuff on here, but it's this HPC topics recording. So let me go. Let me see if I can just hold on. I might have to pull this up on YouTube. There's a video link. All right, here's the video link for it. So somebody asked for the video link, so there you go. I think if I click on that, hold on, let me go click on that, make sure that that'll pop up. Yeah. And then I go into get ads on my own video. That's wonderful, huh?
What are you doing?
What do I need contacts for? I'm wearing glasses. There you go. Oh, this is back before I was running a green screen, but I'm not running a green screen today either, so there you go. Boom. Okay. Anyways, there's a whole bunch of stuff there. I haven't even linked Discord in a while, but let me do Discord. There's Discord, and if people want to hop in there and talk shop with other engineers, we're up to almost 3,000 people. I'm actually hoping to break 3,000 today. That would be kind of cool. I'm just going to hang out on here until you guys get over 1,000. That would be fun. But let's see, how many are we at? Hold on. I say over 1,000. I said 3,000. 3,000. Hold on. Where are we at? Let's go look. I got mentions and stuff, but let's go look at members. We are at 29.6. We need 40 more of you. 40 more of you to become free Prolog engineers with us. It's all free. We don't charge nothing down there. Also, there's a Linux Systems Administration course. We're in week 4 of it now, as of yesterday. I recorded it this morning, so you guys have the recording of it. Those are all free as well, and all the materials down in our Discord. So if any of you guys are hanging out and you're like, I don't know what I want to do in life. Well, go do the Linux System Administration, and then the worst thing you could do there is just quit it. You know, I mean, who cares? It's free. It didn't cost you nothing. One of the guys pointed out, and I'm not going to mention that, but one of the guys pointed out there's a lot of value to what I'm doing there for you guys, and I know that because I know that if you went and sat in a 1-week course and we just compressed it all down to 1 week, 8 hours a day, it would probably be worth a lot. So, too big to fit. I think you're in there. Go see if you see the Prolog Discord. That's Prolog right there. Professional Linux Users Group. Also, looks like people are down there working on stuff. Somebody's down there streaming. So people are working on stuff right now. You guys can go in there and start learning Linux. They're working on their I know at least 2 of these people, maybe I know the 3rd one. You can get in there and start working on stuff right now if you wanted to, right? They're learning and working on something, right? All right. So this is the conscious competence model. We're not going to spend a lot of time in this. The theme of this is learn how you learn, and go learn about the conscious competence model. Go learn about Bloom's taxonomy in some way. We won't spend a whole lot of time here because we're not doing it right now, like fully doing it. But the ISC squared certifications, the CompTIA, the Linux Foundation, the cloud certs, there are a lot of certs that are out there that are pretty valuable in this industry. There's a lot of things that you can go spend time with and bolster your resume in some way to make you just more. I mean, I call these things positive differentiators. When somebody looks at a resume, it's just one more positive thing. I think of the same thing with like a bachelor's degree. I don't think you need a bachelor's degree to get in this industry. But does a bachelor's degree help you to get into this industry? Yes. But do you need it to get in the industry? No. But would it have helped? Probably. Right? And in some ways, in some places, you do need a bachelor's degree to get into the industry. It just depends on what you're doing. Like when I went to work for Lockheed Martin, they wouldn't have hired me if I didn't have a master's at the time. They told me that. They're like, you needed at least a bachelor's degree, but a master's was preferred, and we picked you because you had a master's. And I'm like, all right, fair enough. So we come down here. We can pick up certs. There's a bunch of places to study. There's a bunch of things to go learn about. Here are all the free training certs that I knew about when I wrote this. I should probably update this. I need to update the API Academy.co. That's different now. But there's general engineering. There's networking type of stuff. There's all these ways out there for you to get more positive differentiation of you versus the competition for getting a job somewhere. Right? What do you want to do? What do you want to study? Like if you're like, oh, none of this stuff's interesting to me, but what's that chaos engineering? Well, there's hours and hours of stuff to read right here from this guy Dastragon. He's got a nice little, I'm gonna pull this up real quick. He's got a nice little GitHub that has probably, if I had to guess, about 1,000 hours worth of reading and just work and things for you to go spend your time on around chaos engineering. And chaos engineering is a big part of software reliability or site reliability engineering, right? SRE, and Gremlin is a big one. Chaos Toolkit, FIS, Fault Injection Simulator, right? Inside of things, there's all kinds of these, and you can go throw these on a system and practice. Some of you guys are looking for projects on your Linux Systems Administration course. Here's a bunch of tools that maybe one of these might be an interesting tool for you. Right? I don't know anything about any of these tools, but I know some about Gremlin. But I don't know anything about a bunch of these. But maybe some of these can help you build your skills in that area, right? All right. Have physics degree, but got mechanical engineering role because I was an industrial mechanic for 6 years. It's hard for me to switch into IT with my experience. Or is it hard? I think if you, it depends what you want to do, right? I'd say start building skills around these different topics we've been talking about. Go get in there and work on. Oh, the Dastragon. Yeah, I'll link Dastragon. Hold on. I always forget. Sometimes you guys haven't been around for it, but yeah, here's Dastragon. I think this is one of the best things around if you guys want to go spend time with that. But for somebody who's already an engineer, like I don't know how to say that. 79. I'm going to call you 79. I would say I'd focus, if you're already good on like the math and the stats part of things, I'd go find my Six Sigma and my Lean Six Sigma and start looking at improving processes, because I don't care what type of engineering you do, these are good for you. This is good engineering. Understanding how to get better. And the only reason I only have the white belt on here is because those are the free ones. But then also you can go further down into the different areas. You don't have to just do the white belt stuff. You can go further on if you want, right? There's a bunch of certification out there where the training is free, but the certification is not. And there's a whole bunch of these. Like Killer Coda, all that stuff is free on Killer Coda. I think that's the best site on the web, right there. If I just had a whole slide deck that was just Killer Coda on every slide, I'd still think that's one of the best things you could do on the web. Go get your hands on the actual systems and learn how to do this stuff, right? But there's all these other things that you can go study. If you guys want to get into data science, but you're not on Kaggle, I'd tell you, what are you doing? Like, what are you even doing? If you want to get into Linux security and you're not doing stuff with like Portswigger, or you're not doing stuff with these different things. You tell me, hey, Scott, I want to be offensive security. I want to do like, I want to go attack and do red team stuff like I used to do. Yeah, you got to go get involved with the people that are doing that kind of stuff. In fact, I would tell you, go get into their, go get into their study groups and get into their Discords. Linux is a great place to start, and I think Linux is like the basis for all types of engineering. I think Linux is probably the best basis for all types of computer engineering, but if you want to focus on security, I'd go get into some of the security things. Hang out in the Linux group. I'm not kicking you out or nothing. I'm just saying, I'm going to basically teach you how to do the command line stuff that Kali's going to have all these tools on top of, right? That kind of stuff. Kali. Should just call it Backtrack. Should just call it Wapix. WHOPPIX. That's what it used to be called back in the day. Build yourself a home lab. All right. Guys, what time is it? Oh, I've been doing this over 2 hours. Let me take a break real quick. I'm gonna put Ranger Cam up. You guys can go hang out on and watch Ranger Cam for a second. Where's Ranger at? You guys keep an eye on Ranger for me. How's that dog doing? That dog down there. I'm gonna leave you guys on Ranger Cam. You guys guard Ranger for me. All right. Turn myself off here. Back to Ranger Cam. And let me pull up a hourglass. Yeah, capture the flag stuff is always fun, for sure. I'll just say break and watch Ranger. We'll do 8 minutes. Take an 8-minute break. I'm going to walk around for a second. All right. Yeah, Ranger is the best guard dog I know. But it is 107 degrees outside, and it is only 73 downstairs, so he is nice and comfy downstairs. So, all right. I'll be back, guys. I'm going to take a walk real quick. Oh, is Ranger having doggy dreams and running around? You guys see that? Easy money. If you're a Linux administrator, why not main Linux? Because I don't use Linux for productivity tasks. I do Linux to run giant systems and automate things and that kind of stuff, but I don't need to use it. Also, funny enough, Linux desktop is fantastically bad. It is fantastically bad at almost everything. And I've run, like when I was in college 20 years ago, I ran Linux desktop the whole time. But it's fantastically bad. You can't play games on it. You can't do all kinds of stuff on it. So it's getting better, but it's still not that. But yeah, I don't think. And by the way, that's one of those things like you can do once you get to a terminal. You should be able to do anything you need to, and you should be able to decouple that from what you're using as your productivity device. So there you go. That's my answer. If that's hard, well, you know, I don't know. I don't know what to tell you. Also, it's funny. Just yesterday, one of the guys was making fun of it, but then he couldn't do what I'm doing right there in it, which is closed captioning. So it's kind of funny. All right. Anyways, I'm back. 3 minutes, 47 seconds. We'll keep watching Ranger, and we'll get back to building stuff out. Is there a... Let me see here. Do I have... Well, I won't do it on one time, but we'll see if this keeps happening. Donica said, "What is a home lab?" So building a home lab is all about building out systems in your home. And I know some people don't think you can do that from a Windows box, but you go here and you build a set of servers that are virtual, or in my case, I have 3 physical servers that sit in half rack directly behind me. And then those servers have multiple virtual machines on top of them, right? And then those multiple virtual machines I can hop into from a terminal, right? Which is how we get to doing our actual tasks. And then in here I can jump into any of the systems that I need to. I can do my Ansible. If I need to hit like a bunch of servers for like, I just want to see the uptime on them because everybody's using these lab servers. So then I can go hit them all and that kind of stuff. Yeah. Yeah, Linux desktop. The best Linux desktop I ever remember was there was an old Ubuntu one that was very, very close to like what Windows Aero was. If anybody ever remembers Windows Aero, AERO, it was like the worst thing ever. But you used to basically be able to pop out your desktop and turn it. Never stayed with Windows. They didn't stick with it. But the there was an Ubuntu version of that called, oh God, what was that? But yeah, it was fantastically bad. So what's going on here? There we go. We can see all the lab devices. I need to reboot all the lab devices. So let's go see if anybody's in there real quick. Hold on. So let's see what users are going on lab devices, and then we might need to reboot them all because let's see if anybody's on there. Yeah, we got a few people in there. So what I will do is I'll wait until later, and then because what happens is when you have Werewolf as the front end of your cluster, all your devices are stateless underneath it. So if we reboot any of these, like if I go to Rocky 17 real quick, and then I go and uptime W, nobody's on it, I just reboot this node, right? What'll happen over here on my home lab is I can watch that system boot at the console, right? It's a virtual machine, so there's no physical console to it, but we can watch that system come back up over here. And as it boots up, we're going to see that it's going to do an iPXE boot. It's going to pull the information from Werewolf. We can actually come over here and tail-F on like var log Werewolf log, and we can watch this system as it boots. It's going to pull its information over here, right? Planning on building a NAS. Yeah, NAS is good. I run, so in my home lab, I can show you guys the architecture of some of my stuff. Let me see what's going on here. The wife is texting me on my way home, 45 minutes. What would I like to eat? Let's do... Okay. While that's going, watch. So this is now grabbing an iPixie boot. It's coming up as an image. It's got the kernel image and the init FS, which are the two things it needs to be able to start. And then it would call eventually. We're done with our break, by the way. We were already done with our break. What this would do is this would call, if it had a local file system, it would then mount the file system from the init FS, and then it would be done with all that, and then it would be a running system with a file system underneath it, right? What happens here, though, is a tempfs is built. So we're running tempfs on these nodes, and tempfs is built in memory. So memory is the location of our root on these systems. So watch, when this gets done building, now we see all these systems coming in and checking in to find their overlays, and that's because Werewolf constantly sends overlays. But right in here for a second, we should have seen Rocky 17 booting. But we see him over here booting as well. All right, so watch this real quick. We'll go in there. So we'll jump back into Rocky 17. Give him a second here. Frustrating. When this comes up. When this comes up. Almost done. He should be booting here in a second. Booting here in a second. It's a little slower than it used to be because we added SE Linux in, so now there's a little more SE Linux considerations to the box than there was before. But it's coming. Hold on. Box is coming up. No reason for one node not to come up compared to all the other ones. I wonder if there's something. It should be fine. We'll let that go, but we won't troubleshoot that right now anyways, even if it doesn't come up. Because, oh, there he is. There he is. His SBIN init gets called. He comes up, and then he mounts his disks. And as soon as that happens, he'll drop to a shell on the console, because we could log in. But over here, SSH will start, and then there we go. All right, so what I wanted to show you real quick is the question was... Let's clear... In my home lab, I have a server called Hostbox. It's one of the few boxes in my environment that I care about. But we'll SSH over to Hostbox. And what Hostbox does in my environment, his name's Hostbox, that's all he does. He has two things. If I do show mount -e, he shares out these NFS shares, right? Show mount is an NFS thing. If I do systemctl status NFS, I should see that the NFS server is running, and it's been running for a long time, and here are the shared out things. Now, the ISOs in there, so I'm going to clear the screen real quick, and I'm going to cat ls ISOs. Here's all the ISOs that are in there. Now, if I come to this Rocky 17 box, and for some reason I just wanted to build one of these ISOs, look at all these ISOs right here. Alien Vault, Alma, Alpine, CentOS, CentOS 7, all of these, right? But if I come back and look over here, those are all those same names. So those NFS, this NFS ISO library is actually mounted from my host box, right? So this was somebody mentioned, Ragnarox was talking about building a NAS server. But with just a basic Linux server, watch this. I'm going to do test parm, and test parm, which is not test parmesan, will tell me that I'm running Samba on this machine. And Samba is based on the protocol that was released in 1992 called SMB, Server Message Block, which was written by Microsoft, by the way. And Microsoft wanted to interact, Server Message Block wanted to interact with Unix style file systems, so they wrote SMB. So Samba here for my host box, if I just cd, let's do my show mount -e again. And if I cd to data, and ls in there, I've got all these, there's all these Jiu-Jitsu videos, right? And I've got some backup and some other stuff. But this is my data drive right here. Now watch this. I come over to a Windows machine, right? I come to a Windows machine in real time. And I go to my ISO's data or camera. I go to my data right here. Here are all those videos right there. So maybe I wanted to watch this Lockdown Magnus Hansen video, right? Where's Lockdown Magnus Hansen. So I go in here and I open this. This is over the network. This is over the network. I am watching his video now over the network out of Samba. Right? He's showing some jiu-jitsu stuff, doing lockdown and doing the stomp and doing some other stuff like that. Well, anyways, my point is I can have all of that in there. I can back up into that. I have backup stuff in there, but it's an always mounted protected share on my local system. If I ever have to blow away this laptop sitting in front of me, this laptop is irrelevant. I can just reconnect to my ISOs. There's all my ISOs. There's all my data. And there's all that stuff. And that is functioning as my network attached storage, even though it's just some Linux box out there in my environment, right? I also have some camera stuff. I think that mostly does that do Ranger stuff? Well, let me go look at that. I haven't looked at this in a long time. I know it's being shared out. I just haven't looked at it in a long time. Yeah. Oh, so this is camera data all the way back to 2016. Oh, wow. I wonder how far that goes. So this is today. So this is loading camera data today. And these are captures of Ranger. So this is like if you wanted to see like a picture of Ranger today, that's probably Ranger. I hope that's Ranger, not something scary. Yeah, Ranger walking around on his little bed downstairs. So my camera's constantly feeding in pictures and movies. There's movies down here too, of every time Ranger moves. You guys want to see Ranger move around at like 8:35 a.m.? This is Ranger moving around at like 8:35 a.m. this morning. Yeah, there's Ranger. I got all the times Ranger ever moved around. Right? That dog. Laziest dog I know. But he's a good dog. So, all right. Anyway, so my point in showing you guys all that was, you know, you can get to Home Lab can do all kinds of things for you. And if you're going to build a NAS, you could also probably do all the things you need with just a simple Linux box. You don't have to run, and then you can lock it all down yourself. You lock down your own security. That user that allows me to connect to that off of my Windows machine is I have to be in the Samba group and I have to know the password to open that and access that. Now it's always connected on my machine, but my machine locks when I'm not here. So there's my protection, right? All my stuff back there in the lab costs probably about $700 now, but a lot of stuff was just given to me over the years, or I just picked it up from people that didn't want it anymore. So a lot of my physical machines, I think I bought a couple of these for a couple $100 each, and then I got the half rack, and I think this one was free. So yeah, probably a few $100, right? Pretty cheap for. I've run my home lab for over 5 years, right? And I test things on. I build stuff out there all the time, just for fun. I think then inside of your lab, you should build personal stuff that's interesting to you. And I think you should build professional stuff that's interesting to you that you still use professionally, right? So these are the things that I think you should do in your lab. Now, this is an important one, I think. I think you should keep a book collection. Remember, the topic of this is excelling in the engineering field after college. But also, if you're not going to college or not going to, this is just a talk about how to get better at engineering in general, if you're already in the field, right? So book collection, I think you should have a good reference. IT books, they just go away. Like they're only effective for a little while before they're not as effective anymore. Obviously the technology gets older, things change, but some things stay for a long time. And look, there's no question that Stack Overflow has kept the internet running for the last 20 years. Stack Overflow is every question you've probably asked as an engineer over the years or as an administrator has taken you right to Stack Overflow. And there's always the problem and there's always the answer. And that's been a model that's worked really well, right? Stack Overflow is great. In fact, I saw a thing the other day. Stack Overflow is down like 90% of traffic to it. 90% drop off because of so many people using AI and stuff. So I thought that was kind of an interesting little thing, right? All things tend to go away over time, right? But I think that while that's great, you will find a deeper technical knowledge from reading books because people spent more rigor around it. They did more, they had more people review it. There's just more to it than just some post that has 400 upvotes on a Stack Overflow post, right? So you can pay for books. There's Humble Bundle. LeanPub is good. We've got a book out there that's you don't have to buy, but it's all about labs. Then there's free books online. The site reliability engineering books from Google are free. In fact, I've been having some of you guys read some of these, right? Some of you guys for the Linux Systems Administration, we've been reading topics out of these books because site reliability engineering and operations work go hand in hand. Because operations only cares about uptime and keeping your systems running and making money. And site reliability engineering is around the testing of and building out processes that keep your system more reliable. So they are both tasks that are people that are tasked with 100% uptime in the system if it can be achieved. Yeah, it was the traffic dropped off huge after these different AI models started coming out 100%. Yeah, I read that the other day. There was an article on it. Look at that. Look at Ranger. He looks like he's sad, but I assure you guys, man, that dog is pampered. That dog lives a real nice life. Anyway, so book collection, industry discussion, right? I'm going to tell you guys the same thing I tell everybody. If you can't stand our group or you can't like spend one more minute listening to me, find somebody. If it's not us, find somebody that you can go spend time with. But just don't get sucked in by infotainment. If your goal is to get better, don't watch 6 hours of people. You know, I'm not even gonna discuss the things that bug me on the internet, but just don't get sucked in by that stuff. Find somebody who's actually teaching you stuff. Find something that's interesting to you. Go, I don't know, maybe even buy stuff off of Udemy or something like that. But find podcasts that are not about like incensing you and working you up. They're about getting better at the technology, right? Find a Slack or a Discord about groups that you're interested in. So Measure Camp. I always bring up Measure Camp and Measure Slack. Some of you guys have heard me say this before, but one of my buddies built his whole career on he got a simple little data analytics role at U-Haul. He worked his way up to running all of their data analytics, and he did it because he joined Measure Slack, which I only have this link to them, but Measure Camp or look up Measure Slack, and they have like 30,000 people in their Slack channels, and they just talk about Google Analytics and Adobe Analytics and like web page analytics stuff. And that's what my friend Jared does. And he comes and talks to the group about once every 3 months. I get him in talking, but look at that dog. He comes in and he'll tell you he built his whole career around being on there and asking questions and talking to people about what he should be reading and what he should be studying. And he has a career, like he comes in and tells you guys, he's like, I was making what I thought was the max I was ever going to make again. And he was down here making nothing. And now he's making, I don't want to put his business out there, but he's told people before he makes pretty close to $200K a year. With bonuses, he's probably a little over, right? And that's pretty damn good money, right? So getting involved with, and he did that in 5 years. He went from he was about 40 something K a year to that. And because he worked his ass off and learned things and spent time doing that instead of getting sucked in with bullshit, right? People that just want to tell you that it's NeoVim or nothing, right? It's this tool or nothing. And you're like, okay, I don't know what engineers did before they had NeoVim, but God, now that they have NeoVim, they can actually do engineering, right? Like, I mean, if you believe the history, rocket science used to be done on just chalkboards, right? Like people had chalkboards when they learned engineering back in the day before we all had computers in our hands, right? That kind of stuff. Get involved in open source projects. If you don't want to do just generic open source stuff, there's high performance compute stuff out there. These are both pretty new projects. They're still, HPSF.io was pretty new May 13th of this year. So it's still pretty new, right? All that kind of stuff. All right. Hundreds of free online labs, maybe even thousands now. There's all kinds of government resources. I always tell you guys about the NOAA. I've been involved with NOAA for about 5 years now, and you can go to any of their library seminars. I don't think it's limited to only U.S. I've never seen them say only people in the U.S., but I'll tell you, they will show you how to access their open data platform, and I know people out in Europe use it, so there's definitely some of that stuff that's available. So, hey, Pebble with the rating party of 19. Hopefully this stuff's useful to you guys. We are hanging out talking about how to get better in systems engineering. And I was about to ask a question or answer a question on iCell hats. What about reverse engineering as a way to learn? Yeah, iCell hats, I would say using that to learn engineering is probably learning engineering the hard way. I mean, I guess if you want to do that, that's fine. Main method in Soviet countries as books were very limited and there was no internet. Yeah, yeah. I sell foil hats. I would tell you, like, you can learn that way. You can learn by just sending inputs into a system and seeing what outputs you get. And I mean, this is how people reverse engineer electronic systems. This is how people reverse engineer API platforms. There's all kinds of stuff like that. But at the end of the day, that goes back to that terminology I was mentioning earlier about hacking. And it's this idea that you're just sending inputs to a system to see what the outputs are. And the better you are at that, sure, that's good. But that's not a super efficient way to learn. I would spend time with some of these, resources that are out there first before I would go spending time on that. But look, some people, that's what they want to do for their career. So I'd tell you, keep doing it. Sure. Okay. All these labs, the library guide. Yeah, I'm a big fan of NOAA. Like, I think NOAA is one of the best things out there for people that want to be amateur data scientists. I built their high performance compute system that they still run on right now. If I look up Dogwood and Cactus, this is from one of the, normally, like, I don't talk about things unless they've been released, but when they released information about it, then I could talk about it, right? But this is one of the systems that I helped build. And you say, well, Scott, when you say you helped build it, what do you mean? I was the guy that wrote all the Ansible that maintained how those systems were deployed and maintained the images of all those systems. There's about 2,600 nodes in Phoenix, Arizona, about 4 miles from me, and then there's about 2,600 nodes out in Manassas, Virginia, and they talk about that here. Otherwise, I wouldn't say that, right? But they do weather modeling. If you guys don't know, NOAA does a full weather model every 6 hours, all the time, and they have to run it because all kinds of companies and governments around the world require NOAA to be there so that they can then do all their weather model mapping. And you say even like Europe and stuff, yeah, Europe and a lot of Asian countries rather use. When I say Europe, I mean like countries of Europe, obviously, use the weather mapping. And you say, well, do they? There's agreements and there's costs involved in there. There's open models that anybody can use. Like I could go download them right now. There's open stuff, but there's also stuff that you can get agreements and contracts for as well with NOAA. But I was showing you guys earlier how NOAA has just free seminars. You just want to start using their data. There's free seminars all over the place. There's like seriously probably 2 to 3 a week. What's this guy talking about? On October 1st, this guy's going to talk. He's an associate scientist from Cooperative Institute for Marine and Atmospheric Studies, and he's going to talk about collaboration between community activists and local scientists in La Crosse, Wisconsin. That's Wisconsin, right? Yeah. Work to understand the health risks of recycled tires used in playgrounds and make the switch to natural wood. And then he's going to come and talk about what he was doing and all that kind of stuff. All right, so there you go. Boom. Ranger's good. What's the question? Hold on. Studying electronics engineering, computer science, what's the best job position you recommend for me? Sammy, I try to stay away from telling people exactly what they should do, but I tell you, one of the things I would definitely do is spend some time on like DICE or Monster and then look at kind of the skills that you're getting and then compare that to kind of what you want to do and then start building like a gap analysis of like, hey, I'm getting really good at soldering and I'm getting really good at understanding my programmable logic, my PLCs and all those kind of things. I'm understanding those, but that's not really what I want to do. So maybe I want to go do something around, you gotta, we were talking about it earlier, is like, you gotta find what's interesting to you. Oh, you did CID, CD for them. Ragnarok's, no, I guess I did build, I wouldn't call it CI/CD. I did the low-level systems engineering for their platform engineering. And I guess in some ways, I did kind of do CI/CD, but it was more of, instead of continuous integration and continuous deployment, which is what that means, kind of, but not really. Like, you guys gotta understand, like, the Lego bricks come out and other things turn into other things. What I did was, as the servers came up from their HPCM tool, which was originally before that Shasta, I would say, okay, this is a blank machine that needs to be configured in a certain way based on its name or all kinds of different characteristics that it could have. And then that server comes up and it connects to a network. It connects to a few networks, but then over its fast network, it pulls down the configuration that it needs and it implants itself with the right information. So what I actually did with them was so Ansible pushes, but I inverted Ansible, and every node that comes up pulls down and sets Ansible configurations on itself. And the reason I did that was it's very hard to push 2,600 nodes with, hundreds of configurations. It's very easy to have the node configure itself. So when I did that, we had one of our requirements was for 2,600 nodes, we had to go from bare metal to working in under an hour. And my part of the setup only took 5 minutes. So when we would do some testing and stuff, and we'd go down to bare metal, and then we'd bring the system up, and I'd say, okay, all my systems are up, and they'd go, wow, really? Like we were like stop watching when it was happening, and they thought that it was going to take me into the 20 or 30 minute mark, but we were done at like the 12-minute mark, and they're like, really? We're ready to start up software? And I said, all my systems are up. I can validate right now all my systems are up and working. They configured themselves in 5 minutes. We don't have to sit around and wait. Now, when you bring 2,600 nodes up, just so you guys know, you'll have one or two outliers that don't come up. That's part of Pareto's rule, right? You're always going to have that. But we would, when I would do that, I would go and I would, obviously then go remediate them. But the bulk of the systems are running. And as long as they're not like a critical infrastructure piece, you can get away with, if you have 2,000 compute nodes, 4 of them not coming up. In fact, you expect that. You expect nodes to not come up. Interested in cybersecurity? Yeah, everybody's interested in cybersecurity, but then you got to kind of think about what you're actually doing. Sammy, you got to, if you really want to do cybersecurity, go find a group that's doing cybersecurity and ask them about it. We do some cybersecurity in general around here, but mostly stuff that's like a side to just doing straight Linux, right? In fact, in our group, hold on. I don't have it up anymore, but in our syllabus for the next 3 weeks, our Linux Systems Administration group is focusing on security. So it's that kind of stuff. There's fun free labs online. Yeah, there's all this stuff. All right, so anyways, review. We talked about learning how you learn. It's good to know what's valuable and how you learn stuff. Get certifications if that's interesting to you. Go to college if that's interesting to you. But you don't need those things. It's just a positive differentiator. It's good. If you're in college, stay in college, right? I'm a college professor. I tell people I started to go to college in the year 2000, and I just haven't ever stopped going. And you say, wait, are you still going to college? Technically, I am working on my doctorate, but also I have been a college professor for the last 16 years. So it's basically just like I got a degree and then I turned around and started teaching at another organization, right? I've just been teaching forever. So learning how you learn and learning like how to stuff things into your brain is very valuable to you. Get certifications if that's interesting to you. Build a home lab. If you don't want to build a home lab from the things that I showed you, go deploy stuff out in the cloud. You can deploy AWS stuff for damn near free for the whole first year that you have it. And I told you guys this, and some of you might not believe me, but if you guys were around back when I did it, when I got my certified cloud practitioner, solutions architect associate, and then my security specialty for AWS, I did not spend $1 in the cloud. I did not spend $1 of AWS resources in those 2 months it took me to take those three certs. I didn't. And then I did my developer associate, and then I did my solutions architect pro, and those are my 5. Yeah. But I didn't spend any money out in the cloud doing that stuff. I would deploy services and tear them down, and deploy them and tear them down. And I think that you guys can learn quite a bit in that space. So, all right. Anyway, so that's our review. That was what we were doing. Questions, hit me up on Discord if you guys want. I'll probably get off here soon. The wife's coming home. But we were talking about where do you go to focus on being a better engineer? Like, how do we get better at engineering? And it's like anything. How do you get better at it? You do it. And then you learn how to do it smarter so that you're not just doing stuff randomly. You're focusing on, what are the tasks to be a better engineer? Are you trying to improve processes? Are you trying to understand the systems that you're building? Are you understanding? So again, engineering is planning, hacking, and documenting. That's what engineering is. Hacking is just about sending inputs into a system and being as precise as you can to figure out how it works. But planning and documenting are these other things. Can you model? Can you outline things? Can you estimate how long it takes you to do things with scientific wild-ass guesses? Can you predict possible issues that come up and failures? Can you build a minimum viable product? Can you build a proof of concept to show somebody, hey, this is my model of how things should work? Can you check off a bunch of boxes and say that the capabilities are there? Can you do fit for warranty, meaning it'll work all the times it needs to in the future? These are things that engineers do. Then at the end, we apply documentation to our hacking. Remember I said planning, hacking, documenting? We get to documenting, take notes from our terminal. Can we pull information out in real time and throw it up in our notepads? Do you have a notepad that's always open? This is notes I took while we were just talking. No, I'm just kidding. These were already here. But these are notes that I've been building about actual job board requirements from our Linux Systems Administration course. People went and found real jobs, and I just started adding. So this is the job requirement: stay current with industry trends and practices related to Linux administration. And these were my things that I said that you should maybe go do. Right? This one was install, configure, and maintain computer systems, servers, and networks. And these were the things that I said that you needed to go study or do. Right? And these are all up in the Discord. These kind of things. Clean up and prepare your initial documentation. Run red lines to make your documentation better. Red lines are basically you hand your procedures to somebody who doesn't know anything about it, and you let them run through it. And they will show you by failing where your failures are in your documentation. Your documentation needs to be so good on a project that you can give it to another company and they can do it. And that's very true when I did government contracting. Lockheed Martin did not have the contract over where we were deploying our stuff to implement it. Some other company like General Dynamics or somebody did. I don't even remember. And they would come in. We would build everything and send it out, and they got to set it up. And they loved saying, oh, their procedures didn't work right. They loved saying it. So I made sure my stuff never got that said about it. My stuff always worked out in the factory, from our factory to our production site, right? And then you got to understand how to produce training and operationalize activities from your documentation. So pulling out tasks and events and kind of like a run book of the system for things that have to be able to happen. So you have to assume no knowledge of the system, even with root level operators. Sometimes people manage to get root and they're like a post turtle. They don't know how they got up there. They don't know what they're doing. Maybe do a documentation lesson class after the sysadmin. Yeah, Nezor, I'm going to do... I was talking about it today, and some people were asking. I might do a security, or I might do an engineering one, just a straight engineering one for Linux, and I might do a security one as well. So we'll figure it out. We'll get some cadence after this class, and we'll see what kind of workload I have. You guys got to remember, I'm almost done. Well, I'm finishing the first year of my doctorate, so I'm writing a lot. I write about 8 to 10 pages a week outside of this stuff. And outside of my working and outside of my teaching, I do quite a bit of other stuff. So you guys got to remember I'm super busy. But I'm trying to I want to keep running the Linux System Administration course that we've got going, because I want you guys to kind of know that, if I can stick with it, I'm pretty sure you guys can too. By the way, in our Discord's free. There's a Prolog projects, and there are all of the lab items and all of the items for our Linux Systems Administration course. We just started week 4 yesterday. You still have time to catch up for any of you that are interested. We're doing a 16-week course that's going to end all the way in December, so you're just working on stuff. You're doing discussion posts and talking with other engineers. You're doing labs. You're doing worksheets. You're doing a big project. You're doing a lot of stuff if you're doing it. Honestly, it's probably like 8 to 10 hours a week of work. But hopefully some of you that are doing it are feeling like, hey, it's like going to the gym and benching every few days. You're like, oh, I start to feel that. And then you start squatting, and then you start deadlifting, and all of a sudden you're doing the big 3 lifts, and you're getting stronger everywhere, and you're like, wow, this is working. Well, it's the same thing here. You're working through these processes, and you're building your administrative thought process of being an operator. And if nothing else, when you're all done with the 16-week course, if I were to say, okay, now you guys are going to maintain my home lab for me, you should feel comfortable saying, okay, this week is my week to maintain the home lab. And you should be able to get in there and monitor it and do these things, because we're going to have practiced it all. And then when we're done, you're going to be able to hand off to the next person and say, okay, there were no problems, or there were these problems this week, and this is how I fixed them, and this, and you're going to feel more comfortable doing that for a company. Because what is an operator really doing? They're taking the mantle of all of that work that's happening over systems for a company, and they're saying, I will be responsible for this uptime. And that's a lot of responsibility. I was telling my wife the other day, I'm never going to do this, but I'm just going to tell you as a hypothetical. When I go into work, if I just hit a reboot across everything, I could cost companies millions of dollars. I could have put like AAA when I used to work there. I could have put them on the news. I could turn off everything. I was the platform engineering lead for the whole company. I could turn off everything in the company back then. I'd never even in a million years do it. But what I'm saying is, obviously there's jail time involved with that too. But I'm saying like they would be on the news and like all their systems would be down. It would be millions of dollars of work to get it back. But that's kind of the process of taking the load of like running systems and knowing, what it is like to be the captain of the ship for the first time and make sure the ship's going the right direction and stuff. So this thing. That's not why I do that, Nezor. The reason I do that is an old Linux thing. So. Atticus, that's actually funny. As I was saying that, I was actually thinking that. I was like, I should give these people root. You guys have root in the lab boxes, but you guys don't have werewolf root. And I think actually we might do that. Maybe people who... Maybe I might start maybe making people the lab administrators and then give that access to people. And that would be a really interesting exercise, because now when I say, oh, guys, it's time to switch the lab over to this, it's going to be their responsibility to go get that done. And I think that would be a really interesting thing, Atticus. I hadn't really thought of that, but I was starting to kind of mull that over. So that's a good catch. That's a good thing for us to do. So, all right, guys, I'm going to find somebody to raid on the Twitch side. YouTube side, unfortunately, I just have to leave you guys all hanging. But let's go find somebody to raid. Let's go figure out what's going on in the world here. Discard all my annotations. And for some of you guys, I'll see you later on this week. I'll be around. Let's see who I can raid here. Who's still hanging out? Let's go hit Rob up. If you guys don't know RWX Rob, he's one of our favorites, and he raided us the other day. So we're gonna go raid over to him. Our raid message is just do all the Linux, right? And I will see some of you guys later. Take care.